Hello, Sudhita, can you switch on your camera if you don't mind? Perfect. Okay. All right. Now I can see all your beautiful faces. All right. So welcome to the astronomy camp hosted by Knox Institute. So today is our first class, right? So this is the first day of our astronomy camp. So I hope all of you all are excited. Are you all excited, kids? Who is excited? Raise your hands if you all excited. Awesome, awesome. I can see everyone raising their hands up. Super. Awesome. All right. So let's not waste time. Let's straight away jump into our camp and let's see what we have today to do, right? Okay. So before I start today's camp, it's better if I just give you all an overview, right? So how this will work out. So basically, I think you all already know. So we'll have our classes, in the sense our camp, every Sundays from 3 to 6 p.m. And then it's 3 hours. So yeah, so from 3 to 6. So basically for the first 2 hours, so that's from 3 to 5, right? So 3 to 5 or 3 to 4:30, I will be explaining various stuff related to the topic that we will be learning. I'll be explaining all of it, and then the remaining 1 hour is for you guys, right? So in that 1 hour, what we'll be doing is y'all can ask us questions. Remember, I told you all in the preparatory session in the trial class that y'all can prepare your questions and stuff. Remember? Who remembers?
Yes, sir.
Right. Right. So have you all prepared your questions that you are supposed to ask? Any questions that you all have in your mind? Right, y'all will have questions, right? So those questions and stuff y'all can ask at the end 1 hour. So that's from 5 to 6 p.m. So that's when we'll have the session where we talk with each other. So at that time y'all can ask all the questions and we will have a really nice session. All right, and the end what we'll be doing is we have an activity for you, a really fun activity which y'all have to work on yourself, all by yourself. And then on the next class, that's in the sense the next Sunday, you all have to show me what you all have done, the activity. Okay, so if you all have finished the activity, you all have to show me that activity on Sunday. It's a really fun activity. It's not like a very boring homework or anything. Very fun activity. You all can play and do it. So so the student who does these activities on time, without any mistakes, correctly and all of that, will be awarded. So at the end of our astronomy camp, you all will receive a really a very good prize. So if you all want to get a prize, I hope all of you all are really talented. All of you all can work for it. So if you all work for it and if you all do this activity properly, you all can win this prize. Okay, perfect. All right, so I'll share the screen with you all. I think I didn't show you all the schedule, I guess, on the what you call the trial class. So today I'll show you all the schedule for this month, January, so that you all have an idea of what we will be doing. Okay, so just one moment, kid, one moment. Kids, and another thing, it's better if you all can keep your mics muted. If you all have any questions to ask, then you all can unmute your mic and then ask these questions. All right, Shanuli, if you don't mind, can you mute your mic, and if you have any questions, you all can ask. All right. Okay, so let me show you all. Guys, can you see the screen? Can you see my screen?
Yes.
Awesome. Okay. All right. So y'all can see the screen, right? So today is week 1, right? So today is the first day of our class. I think Imalka was here with us. Arudit also was here. Tisen was here. and who else? What's his name? Chirat was also there, and I think Binal also joined us last trial class, right? So in the trial class, I think I told you all that the first class of our astronomy camp will be based on solar system. So we'll be learning everything that is related to solar system today in this week. So anything that is related to the solar system will be covered today, and y'all can ask questions and stuff. So like I said, the last two sessions is a group discussion where y'all can, we talk with each other. Y'all can talk about whatever y'all know about the solar system. Y'all can ask questions from me about the solar system and all that, right? And seventh is the activity. So today's activity will basically be to draw your favorite planet and its natural satellites. So now don't get panic thinking, okay, what is a natural satellite? Don't worry, I'll explain to you what a satellite is all about, right? Okay, perfect. All right. So before I start today's class, there are a few videos that I have for you all to see. So let's watch that video and then we'll start today's class. Okay, so first we'll watch those two videos. I wanted to show you all those videos in the trial class, but due to time restrictions, I couldn't. But today we'll watch those videos and then we'll jump into our solar system, right? Okay, perfect. Shanuli, if you don't mind, can you mute your mic? Hello, Shanuli. Shanuli, can you mute your mic? I think I can mute it. Okay, okay, perfect. Okay, all right. So let me share the video. Okay, so now today you all might be having different questions in your mind, thinking, okay, why am I learning this? What do you call this camp? What am I gonna get from this astronomy camp? After 3 months, will I have a full knowledge of this astronomy? Will I be an expert of this? Right. So there's a lot of questions for you, for your parents, basically for everyone, right? So we all have to do things which is going to be beneficial for us in future. If it's not going to be beneficial, there is no point doing it, right? So now I'll just show you a video of how students like you, right? So students. So now you see, if you take Imalka, Arudit, Shanuli, Sudita, all of you all are students, right? Children. So just like y'all, there are a set of students who are, fond of astronomy, who likes astronomy so much. They have got together and they have made a rocket and they have sent it to space, right? So even y'all can do something like this, later on after our camp. So let me show you the video. Okay, so let me show that video. Tell me if y'all can see the screen. Okay. Okay, can you see the video, guys? Hello.
I can see.
All right. Okay. I'll play the video.
Teacher.
Awesome, awesome. So I'll play the video. Enjoy. Okay. So this is a video about students just like you, kids just like you. They were really fond of astronomy. They loved astronomy so much. They were so excited about it. And then finally, when they grew up to become, teenagers, like 15, 16, 17 years, they got together and they built a, what do you call, a rocket, and they were able to send it to space, right? So this is something really extraordinary, right? So we as Sri Lankans, we also can do something like this and make our country proud, right? So make take our country's name to a next level, right? Promote our country. So we also can do it. Not only them, even we can do it, right? So perfect. So let's see how these students have worked and built this rocket.
No.
You all can hear, right? You all can hear, right?
No, teacher. No,
Can
sir.
you all hear this?
No. No, sir. No.
Can't you all hear?
No, it's stuck.
What is it? Okay, hold on.
It's stuck, sir. It's stuck
No, I
now.
paused it. I paused it.
Stuck. A little bit. Slowly I'm going. Slowly. Cracked. So, I can't hear.
Okay. That's correct. Okay, now I think y'all will be able to hear, right? Okay, sorry about that. Okay, now tell me if y'all can hear.
At 328,000 feet above the Earth, air is
Now I
too
can
thin
see.
to sustain wind
Now,
flight.
now we can hear.
Can hear, right? The fuel that you need in order to send the rocket, the plan from where they are going to launch this rocket, how they are going to launch this rocket, every single thing is planned by these students. So these students are not that old, right? So I guess most of y'all might be 9-10 years old, right, if I'm not mistaken. So these students are basically, in their teenage, so they are like 16, 17. So it's not that big of a difference. So if y'all work towards your goal, your dreams of becoming astronauts, astrophysicists, and all of that, definitely all can achieve it. Okay, so don't ever think, okay, I'm very hard. This is astronomy is very difficult. I can't get it. How am I going to become an astronaut in future? Don't ever think like that, because anything is possible in this world. You have no idea, right? So look at these kids will do something which they thought is impossible, and they were able to do it. So yeah, let's watch the video.
Pounds of propellant.
We follow a recipe that was created over many years. We were able to come up with a propellant that rivals some propellant
Can you
that's
see
made by
what they were
professional
making in that
companies.
pot? So that is the fuel that is needed for the rocket. So using that fuel is how they will able to send the rocket from Earth to space. Okay. All right.
Excuse me, sir.
PCBs, the structural components
Yes,
had to be
Arvind.
built completely ground up.
The moon contains the rocket fuel.
17 kilometers. 17 kilometers. We are appearing to start to lose lock. Over. We appear to be getting pieces of packets. Over. The drones are fired.
See, their launch was successful, so now they're happy, working so hard for so many months, for so many days with endless nights, right? Without sleeping at night, they worked so hard, and see, now finally they achieved their goal. Their rocket has propelled successfully, and now it's heading onto space. Let's see what happens next. This is the camera that was fitted onto the spaceship, sorry, onto the rocket. It is not that clear, but I think you all can see, right? So you can see this white color thing. Can you see this white color? Like. Of an altitude of 340,000 feet. So 340,000 feet is a very big distance, right? So it has gone so high up into the sky, not a very short distance, a very long distance, a very high distance. It has gone so far. So making it's the first student designed and built rocket ever recovered from space. See, so this is the first time a rocket designed by a student has been, recovered from space. So has been successfully sent to space and then recovered back. First time in history. No one has been able to do it. So you all can be the second set of students in order to do it. Yeah, anything is possible, right? So never lose hope. So you heard him too. Switch on the TV, relay came up on channel 2. Alright, so that's it basically, the video. So did you all enjoy the video, guys? Hello, I hope the video played well.
Yes.
Awesome.
Yes.
All right. Okay, super. Okay, so I'll show the schedule for today. So first we are going to talk about the formation of our solar system, right? So the formation of solar system. I guess some of you all might already know how the solar system, was formed, how it got formed, why it got formed. All of it, some of you all might know, but whereas some of you all might not know as well. So don't worry, I will explain everything in detail as much as possible. And then lastly, I'll give you all a chance in order for you all to speak as well, right? So that's where you all can, prepare your questions, any questions that you all have, prepare those questions, and we'll answer those questions in the sixth part. So the group discussion, I will tell you all when it is, and when that comes up, I'll give you all the chance for you all to speak, right? So you all can speak, ask questions, share your ideas, share your thoughts, and all of it. Now I'll just explain these five topics that I have for today, that I have prepared for today, so that others who have no idea of it will be able to learn it. Okay, perfect, kids. Got it? Understood? Give me a yes if you all understand.
Yes, sir. Yes, sir.
Perfect.
Yes, sir.
Thank you so much. Awesome. All right. I can see few people have switched off their camera. Why is it? Don't you all like to show your faces? Don't be shy. Yeah. All right. All right. Okay. No worries. No worries. Okay. All right. So let's move forward. So formation of our solar system, right? So basically, whatever you take in this world, right? So let's just rather before we move on to the solar system, I'll just give you all a basic example, right? So let's say this. What is this? Can you tell me what is this? What is this I'm wearing? What is that? Headphones, exactly, right? So if I take this exactly. So if I take these headphones, I can definitely find that there might be a sticker somewhere mentioned made in China or made in USA, made in Russia, made in South Africa, somewhere, right? And then also I can see when it was made. Made in the year 2018, made in the year 2019, made in the year 2020. Like that, we can find so much of data, right? So much of information about stuff that is around us. This laptop, these headphones, this phone, this mug, that book, everything has a date when it was made, right? Even you, even me, I have a date of birth, right? You all also have a date of birth. You all celebrate birthday, right? So you all celebrate birthday. So what is this birthday? Birthday is the day where you came into existence, right? The day where you came into this world. Before this birthday, were you there? No. Before my birthday, was I living? No. So just like that, the solar system also has a formation, a day, in the sense, a time where it came into existence. So when you look at the sun, when you look at our solar system, we all know that it has been there for a very long time, right? So even our ancestors have recorded about it. People who lived thousands of years. Yeah. Yes, Imalka.
Our solar system is old. Our solar system is 4.6 million years old, billion years
Super.
old.
Yes, yes. So see, so some of y'all know how old it is. So it's about 4.5 to 4.6 billion years old, right? So it's not a very small time. It's a very long time ago, right? So it didn't happen somewhere last year or the year before that. It happened so many years back, not even millions, it's billions of years ago. All right. So how did they find this? That the what do you call the solar system was made billions of years ago? How did they find this? Yeah.
They collected the oldest matter that in the solar system and see the see when it has formed.
Yes, exactly. So Imalka has some idea of it, how it was formed, right? So let me share something else that I got from the internet.
Excuse
All right.
me, sir.
Yes, Arvind. Yeah.
The solar system was first formed with the nebula and that turned to a star, and then the asteroids collided and made planets.
Yes. Yes, Arvind. Yeah. So
All
perfect, Arvind.
started from the dust cloud and became a nebula.
Exactly, exactly. So we'll talk about all of that. All right. So thank you for that heads up already. All right. So then how did we find? Now I was explaining about the headphones, right? So when I look at the headphones, I can see it is made in China. It was made in the year 2019. It is black in color. It is made out of plastic. All those details I can see looking at the headphones. Similarly, I can say about my laptop, my phone, everything. So when I asked how did humans find out that the solar system is 4.5 to 4.6 billion years old, how were they able to find? So Imalka gave me a really good example. He said that they found the what do you call the matters from space, all the matters from space, and that's how they found it. Exactly. So they did very similar thing. Now, even the video that I showed you, right? So the rockets that were sent by these students. So not only students, even big companies like SpaceX, like NASA, like ISRA, Indian Space Research Agency, European Space Agency. Like this, there are so many space agencies around the world, right? In most of the developed countries. We don't have one in Sri Lanka, unfortunately, but we may have it in future. We don't know about it, but in European countries and in American countries, they have space agencies. Yes, Sudhita, I can't hear you. Yes, yes, SpaceX. Thank you, Sudhita. Yes. So just like that, these, yeah. Yeah. So agencies like this, what they basically do is they always repeatedly they send telescopes, they send rockets, they send probes to space, right? So when they were sending all of this, they came across a meteor called Bennu. Have you heard about it? Have you heard about the meteor called Bennu?
No.
Anyone? All right. So there is this, yeah. So it is considered to be the one of the most oldest celestial solar system, right? So there are other ways that they found the age of our solar system, but similarly, using this meteor called Bennu, humans identified that this Bennu, that meteor, is really old. It is almost old as the solar system itself. All right, so they sent spacecrafts, they sent telescopes in order to observe this Bennu meteor, which is present in our solar system. And they got data from these meteors, and they found that it was roughly about 4.5 to 4.6 billion years old. And that's when they found out that this meteor was in existence when the solar system came into existence, right? So when it was born, this meteor was there. Okay, so now let's see how our solar system came into existence. So now we found how humans found out the age of our solar system. Now let's see how it formed in the first place, right? So 4.5 to 4.6 billion years ago, there are stars, right? So not only our star, so is there only our star in the solar system? Sorry, in our galaxy, or are there any many stars in our galaxy?
There are many
There are
stars in
thousands.
the galaxy.
The biggest star is the thousands of stars.
Look at here.
There are
Exactly.
thousands of stars. And the
Thank
biggest sun is the sun.
Thank you.
The
Thank you.
biggest star is the sun.
Yeah.
For example, R136A1.
Yeah. All right. Thank you, guys.
For
Thank you. Thank
example, Betelgeuse is the special one.
you. Yes. Thank you, Arvind. So thank you all of you all for giving me answers. So we all know that, right? So it's nothing special. We all know that there are so many stars in our galaxies, many stars. So if someone asks us a question like how many stars, now if someone asks a question from me, how many students are there in today's class? It is 7. That's it, right? So there's nothing hard in that. If someone asks me how many stars are there in our galaxy, there is no exact amount because there are millions of galaxies in our solar system. You can't say, okay, there is only 1 million stars in our galaxy or 2 million stars in a galaxy.
Excuse me, sir.
Go ahead. Go ahead.
Andromeda galaxy has more stars than the Milky Way.
Yes, yes, it is exact. It's actually a bit bigger than our Milky Way galaxy. It's much bigger than our Milky Way galaxy. So therefore, it has more stars, right? More stellar systems in its galaxy.
It's more younger.
Similarly, so coming back, yeah. So coming back to our yes. So coming back to formation of a solar system, there were other stars as well in our galaxy before the sun. There were so many stars, like the closest star, like Alpha Centauri, like that. There were so many stars. So the scientists, what they are saying is there used to be a red giant. They are believing. Okay, so this is not something which is 100% true. This is just a theory that they came up with. They said that so many years ago, 4.5 to 4.6 billion years back, there used to be a red giant. I think you all know what a red giant is, right? It's a very huge star. So this red giant ceased to exist. Yes. So this giant, what happened was it exploded, right? It exploded in the sense it came into end. It finished its lifespan over.
Exploded in a supernova.
Supernova, exactly. So that's the term. So so it exploded and it became a supernova. So now this, what is a
the red
supernova?
giant with supernova at the end of its life and produced the nebula.
Yeah, who is that? I think Chirath, right?
And Excuse me,
Who
sir.
spoke
Some of the parts that were
Yeah.
released contain fuel, hydrogen,
Hmm.
and helium.
When nitrogen and helium fuse together, the core produces iron, and then the star runs out of fuel and occurred
Yeah.
in next water.
Yes, exactly.
Sir.
Yes, Simalka, you raise your hand. Yeah.
Excuse
I
me.
know how the solar system formed. It
Yes.
first became as a nebula, and
Hmm.
there were 5 stars that are ready to explode in a supernova around the nebula. When they explode,
Yeah.
it makes a fusion fraction and make heavier elements like hydrogen and helium, and it make the quark star in the middle, and when the other matters were pulled into the quark and became the sun, and the rest of the matter had gone had became planets and the astronaut belts and the Oort cloud, and
Yeah. So yeah. All right, Imal. So you can actually we can discuss about that when we have the group discussion. All right. Okay, perfect. Just keep all of it in your mind. Just note it down in a piece of paper. We can all discuss about it. So now, yeah. So coming back. So basically, this star, the distant star, which was there before our formation of our solar system, it exploded, and all the particles, all the dust particles, the water particles, the gas particles, all of this were there. Like it was all available. There's nothing. It was all building up. The pressure was building up. The temperature was building up. So this is something which we call as a nebula. So what is basically a nebula? I will explain all of it in details when we talk about nebula, but today I don't want to go much into details because we're going to talk about the solar system. So basically, a nebula is some place where a star is basically born. So you call a nebula as just a basic idea of what nebula is. That's where a star is born. So even our star was born, our sun was actually born from a nebula. So these gas particles, these ice particles. Yeah, hello, who is that? Stop. All right, okay, no one. Okay. So these gas particles, these ice particles, all of them were building up. They were the mass of them, the weight of these gas particles were all increasing day by day, day by day, day by day, day by day. And then what happened was they were all starting to fuse together, right? So fusing together in the sense, what does it mean? Coming together, attracting with each other, right? So just like a magnet. Now you keep so many magnets together, what happens? These magnets get attracted to each other, right? So they all paste with each other. So just like that, all of these were pasting, and their gravity, the gravitational pull which was created by this started increasing. It was increasing very much that all the distance, what do you call, meteors and asteroids and all of these started attracting with each other, and the temperature also was increasing just like the gravity, right? So this was happening. So this is not something which happened in a day or two. It took a very long time in order for this to happen, right? So millions of years. And then what happened basically is a protostar was born. Now I'm asking you all a question again, right? So just like I asked a question earlier, a protostar was born. So not our sun. So at the start, just like how I explained, all these gas particles, all of them came into together, they fused together, and a protostar formed. Now I'll just ask a question from Arudit, Timalka, or anyone who is willing to answer. Do you all know what a protostar is? Let's see.
Sort of.
If you all don't know, also it's
star
fine. I'll
that's
explain.
I never heard of that, sir.
I know what's
Yeah, one at a
called
time.
as
Yes.
protostar.
Yeah. All right. Perfect. So you all. Yeah.
baby star, something that is developing but not really a star yet, but it's on the way to becoming a star.
Exactly. Right. So just
If
like Just
It's in a nebula. It's in the middle of a nebula.
yes. Thank you,
I
guys.
never-
Thank you.
I
Yeah,
know.
who's that?
Excuse me, sir. I know.
Yeah. Who is that speaking? I can't. Tisen, who is Tisen, right? Yes, Tisen. Yeah, go ahead. I can hear you.
A protostar is a very young star that is still gathering mass from its parent molecular cloud.
Exactly. Thank you for the answer. Thank you everyone for the answer. Thank you, Marcus,
A protostar
Arudit,
is the
Tisen,
core of the star.
and Shira. Yes. All right. Okay. So now let's see what it is. All right. So thank you for your answers. Okay. So basically the protostar was what formed initially, right? So what is this protostar? So just to make stuff even more clearer, to make us understand what a protostar is much clearer, I'll give you all a very good example, right? So if I ask a question from you guys, are you all babies? Are you all babies?
No, not now.
No, right? No, right.
No.
So you all are kids. You all are kids, right? So now you all are 10 years. So a 10-year-old boy, is a 10-year-old boy a baby? No, right? You all are growing up. So just like me, right? Am I a baby? Am I a baby, guys? Right. I'm not a baby. I'm not a baby. But was I a baby? But was I a baby before?
Yes.
Yes, right?
Yes,
Exactly. Now I didn't just fall from the sky like this. Did I fall from the sky just like this? No, right? I was born and then I was a baby. After I was a baby, I became like 5 years old. I went to school, then I became 10, then I became 15, 20, like that. Now I'm here. So just like that, even our star, the sun, became a protostar. So protostar is basically like a baby. Understood? So protostar is like the baby sun, baby star, right? So that's how any star, it becomes a protostar initially, and only then it becomes a full-grown star. Okay, so now I hope you all understood what it is. So
Yes, sir.
okay, so now yes, who is that? Sudita, right? Yes, Sudita, go ahead. Yes.
Stars like begins with a nebula, and after that, the nebula breaks apart, and then gets a protoid star, and then the protoid star becomes the deep, and then a star is building up inside and near, like in the galaxy, and then
Yes.
releases gas and the particles away and then becomes a star.
Superb. Thank you, Sudita.
Excuse me,
Okay.
sir.
Yeah.
When a protostar is in the middle of the nebula, it will increase pressure and heat,
Yes.
making hydrogen helium fuse. And it's called nuclear fusion. When a nucleus fusion forms, it goes against the gravity and then it becomes slowly light particles come by energy and then slowly turns to a star. And it also releases radiation.
Exactly. Thank you, Arvind. Thank you. Okay. So now we saw what a protostar is, and I also gave you an example, right? So you can compare a protostar with a human baby. So that's the first initial stage of a star's lifespan. So now I'll now discuss with you all about how a protostar is formed, right? So now I explained to you all what a nebula is. So nebula is basically where a star is formed, any star. So nebula consists of particles, and vapor, like that. There are so many things in a nebula, right? So many elements. So yeah. So basically what happens is, due to gravity, these dust and these gas and all of them, they come together just like a magnet. So how a magnet attracts with each other, so like that they all attract. And what happens when all these particles, when they attract, when more and more particles keep attracting day by day, year by year, thousands of years, millions of years, what happens is the gravity also increases. Now, when it comes to gravity, I don't think most of y'all know what gravity is. I guess some of y'all might know what gravity is, but anyhow, some students over here, they don't have an idea what gravity is. So
Gravity stays up on the ground.
Excuse
Yeah,
me, sir.
yes.
Gravity means the gravitational force.
I know gravity.
Kids, I'll give you all chance to speak. I'll give you all chance to speak, right? Yeah. So
Excuse me, sir.
yes.
Gravity means it's the force that makes everything go down, and it was discovered by Isaac Newton.
Exactly.
And
Thank you,
after
Arun.
fall.
Thank you. Super. All right. So that's he actually told who even found gravity, right? So that was Sir Isaac Newton. Yes. Thank you, guys. So I'll give you all chance to speak. Don't worry. I will. Like I said, I showed you all the document, right? So today we are having a group discussion. So definitely I will give you all, each and every one of you all, Imalka, Sudita, or what do you call, Arudit, Binal, everyone will be given equal chance for you all to speak as well, right? So today I'll just first I'll explain, and then I'll give you all chance to speak, because there are a few kids who might not know most of the stuff, right? So if we keep talking, then they might not get most of the stuff. So first I'll explain, and then I'll give every one of y'all a chance to speak. Okay, perfect. Got it, guys? Give me a thumbs up if y'all got it. Thumbs up. Perfect. Super. All of y'all are really good. All of y'all are really intelligent. Y'all know most of the stuff. But when all of us talk, at the same time, some people who don't understand, they might not get it, right? They might feel bored, right? Most of the stuff. And then later on, I'll give you all the chance for you all to, come forward and explain whatever you all do. Okay, so don't worry. I'll give each and every one of you all a chance. All right. So that's basically how a protostar is formed. So with all these particles in the nebula, they all get together. And then once all these particles get together, the more and more particles they get together, the gravitational force increases. So just like Arudit said, he gave us a basic idea. So gravity is basically what keeps all the stuff on the ground, right? So even if I jump now, what happens? Will I stay floating on the sky? No, I will come back to earth, right? So if I put something on the floor, if I have this handkerchief with me, so if I put it, if I let go of my hand, what happens? It falls down. So then basically what happens is gravity is the force which attracts stuff to it, right? So that's because it's because of gravity that the earth is revolving around the sun, and it's because of gravity that we are all on this planet. If there is no gravity force, what basically will happen is there will be chaos all over. I will go flying here, you will go flying there, and no one will be able to live, right? So gravity is a really important force. So it's because of gravity that all these clamps and all these particles and all these atoms, they come together and form this protostar, which is basically the baby star, right? And this process is known as accretion. What is it called? It is called accretion. Yes, Himalka, yes.
When if gravity is not there, all the sugar, salt, sand, all of those things would have a gravitational force that's powerful enough, and we can if we go to the kitchen and get the sugar, we see a bowl of sugar.
Yes, exactly, right? So there's going to be a lot of chaos. I'll just show you all a really good example of how the world will look without gravity, because every single day there's gravity on Earth, right? So there is not a single day where there is no gravity, right? So if I drink tea, right? I have a cup where I drink tea. If I drink the tea and if I keep it.
Excuse me, sir.
So he will float out of the cup.
Yes, Arudit.
Space,
Yeah.
we can. It's no gravity, so we can fly like. We can go any time,
Exactly.
anywhere without falling down.
So true.
After we exit the Earth's atmosphere, no gravity at all.
Exactly. So once
entropy.
Without the gravity will take where the gravity wants. We can't be where
Yeah.
we want. The gravity will take us where the gravity wants.
Exactly. There is no control over it. Yeah.
And the opposite of it is dark energy.
Yeah. So let's not go into that now, Rudit. We'll talk about that. Okay. So in the next few weeks, I have a special day dedicated for dark energy and stuff. So we'll talk about dark energy at that time, right? So today let's talk about gravity. So I'll just show you a small video. Okay, so some of you all might not know what we are trying to discuss over here. So for those people, I will show a video. Even you all can watch the video. We'll all watch the video so that we get a better understanding about how life would be, if there is no gravity, right? So in this earth we are blessed actually, right? So because of gravity is the reason why we are all living a very peaceful life. So Imalka told a really good example. He was like, if there's no gravity, if you go to the kitchen, what do you call the salt bucket, and this sugar and all of that will float here and there, and you will not know what is happening. It will be a total mess. So let me show how these and also Arudit mentioned a really good point, is that you have to escape the earth's gravitational pull in order to set yourself free, right? So wherever there is gravity, you can't do anything, it will attract you towards it, right? It doesn't have to be earth, it can be another planet as well. So even if you go to Mars, it will attract you gravity, and then yeah,
slowly pull down, and the elliptic process orbiting in the earth.
yes, I'm actually going to show you a video. I'm actually going to show you a video of how.
Excuse
Yes,
me,
guys.
sir.
Yeah.
Even too much gravity isn't good. Like Jupiter
Yes.
and Saturn, it has
Yes.
too much gravity that if we could ever go a little bit into its
We'll get crushed.
part of atmosphere, we even can't stand.
True. That's right. Okay, so
We
now
would be a pancake.
so, yeah, that's right. Basically,
We
yes.
have to. We can't even stand.
All
And
right,
the
all right.
high pressure will make
Okay,
us
so
go down. Even there wouldn't be a ground, a solid ground,
Yes.
a solid
Yes.
surface.
We'll discuss about that. Okay, so we'll discuss about that when we have the group discussion. Now I'll just show you a small video. What do you call of how astronauts live in space where there is no gravity, right? So in the ISS, International Space Station. Okay. So can you all see my screen?
Yes.
Sir, I have
You get-
watched exactly that video in
Ah.
grade 1.
Super. So some of you all might have not watched. Yes, so I'll just show you a small clip. Okay, I'm not going to play the entire video, so you can see how cool is that. Look how he is floating, right? He's not putting any effort at all. He's just going like
It's like he's
not like
flying. It's
Yeah.
like he's flying in space.
yeah, he's like Superman, right? So see, he's just moving. So cool. Like, who wants to go to
We
outer
even
space and
can-
experience?
We even can do things on the roof in space.
Yes. So
But
sometimes there's a
but
really cool
the-
thing. Just like Imalka explained, like going to the kitchen, and then I think this guy will drink something. Let's see.
When we drink, we have to squeeze a
Just
bottle.
like water.
Excuse me,
Yeah.
sir.
All the water
Yes.
would be a ball too.
Excuse me, sir.
Yes.
When we need to drink water, we first have to squish it, let the
Yeah.
water drops out, and then
There's a squish bottle, right?
Quickly.
Yes.
quickly drink it by the
Yeah.
floating
So
parts.
in space, they don't use the normal water bottle like how we use in Earth. They are having a squish bottle. So they put that's like a straw. So they put that and they squish it. See how the water is. This is a water bottle.
Some
Because
That's a
of
water
zero
drop.
will
That's a water drop. That's a water drop.
some asteroid will
Excuse
Yes.
me, sir.
squeeze
Excuse
into
me,
Yes, I
sir.
understood.
into
Excuse me, sir. If you
Yeah.
blow a bubble in outer space, it won't keep for real long. In a fraction of a second, it will pop. No air left.
Exactly.
Some astronauts will squeeze the bottle and let the water go out and then drink the bubbles.
Yes, yes. There are videos like that, right? I also have watched. That is really cool, super cool. That is actually right. So hopefully one day we also will get that experience to drink water
If
like
we
that. Okay.
drink
So now
tea
coming back
from
to
a
the
teacup, all the tea will fly out.
yes, exactly.
We need
All right.
something
So now
to cover if we want to drink. Like that.
yes.
We have to take a cover
Okay.
and put a straw if we want to drink tea in a normal cup in outer space.
Okay, guys. Okay. All right. Perfect. Okay. So again, all right. So we are actually running out of time and there is so much to cover. So again, like I said, I'll give you all a chance in the group discussion. We'll talk more about this in the group discussion. Now coming back to the protostar. All right. So we know what a protostar is, how a protostar is formed, where a protostar is formed. It's formed in a nebula. Everything is done. Right. Okay. So now let's discuss how a protostar becomes a star actually, right? So how a baby becomes into an adult, right? So I was a baby once and now I'm like this, right? How did I become like this? So just like that, how did a protostar become into a star? Now I'll explain it to you, right? Okay, so what basically happens is, remember I told you when all these matters they come into when they get attracted to each other, they when their weight increases, when their mass increases, their gravity also increases, right? So just like the gravity, every planet, every star, all of these have a core within themselves, right? So there's something called a core. So this core is something which is always hot. It's always hot. It's extremely hot, right? Yes, exactly. So what happens is this gravity and this gas, right? So what do you call, even if you take our sun, there are two gases which are prominently found in our gas. That's hydrogen and helium. These gases, they heat up. So yes, these gases heat up so much. They are very, very, very hot. You can't even imagine going closer to that, because if we go closer to that, we will evaporate. Will disappear, right? So it's really hot. So this gas pressure and this gravity that is being formed in this protostar, they will increase tremendously. What does that mean? Both of this will increase. The gravity also will increase day by day. The pressure also will increase day by day. So every single day, these two will increase to a point where this gravity and this pressure will become equal to each other. Right? So the pressure that is being built, this amount of heat, the pressure of the gas and the gravity that is being formed will become equal to each other. The day when this becomes equal to each other, that is the day when this protostar will become into a star. Okay, so now talking about our sun, so sun is the closest star to earth, so that is our sun, right? So that is our star. So even our sun had the same life cycle, right? So our sun also was a protostar. The gas pressure increased to a certain limit. The gravity also increased. The pressure also increased. When these both became into a same position, the same limit, when they both became equal, when they both balanced each other, then this protostar became into a star. And that's why when you go out today, when you go out and when you look at the sun is the way how it is. If this hasn't become equal to each other, there wouldn't have been a sun, right? So just imagine 4.5 billion years ago, the gas and the gravity didn't match with each other. They didn't become equal with each other. If this doesn't happen, if this didn't happen at all, there wouldn't have been a sun like how we have a sun when we go out and when we look at it. So there won't be something like that if this had not happened. Okay, so that is basically how a protostar became into a star, right? So now let's see how this gas, right? So this gas that I'm talking about, this gas pressure and gravity, how does these two become equal? Okay, so let's first see
Excuse
how
me.
these two becomes equal. Yes,
Excuse me,
someone
sir.
said excuse me. Yes, Imalka, go ahead.
If
Yes, Imalka, before you start, just give me 1 second, just 1 second. Guys, whoever, if you all have any questions, better if you all just unmute yourself and you all ask, okay, excuse me, sir, because sometimes when everyone talks from my side, it's like, how do I say, like, while everyone is shouting from different sides, it's like noise, I can't understand, right? So if you all have any questions, if you all want to speak, always unmute yourself and ask, sir, I have a question. Then I will tell others to keep quiet, and then you can, once you are done, the next person can speak, and once he is done, the other person can speak. But when everyone talk at the same time, it's very hard to understand. Yes, go ahead, Iman.
our Earth's core is the same. Our core is the produce heat similar to the sun's surface.
Just extremely hot.
If a core is the hot as the sun's surface, could you imagine go inside the sun's core?
Impossible, right? Impossible. That's something which cannot be done. Super.
Well,
So thank you for asking that question. Yes, Sudita, do you have a question to ask? Hello. No questions. Okay, perfect. Okay. What about Arudit? Arudit, you have got any questions to ask?
Excuse me,
Yes.
sir.
Yes, go ahead. You can speak. Yeah. Arudit, yes, speak. I can hear you.
Yes, sir.
Yes.
Okay,
Yeah.
sir. Give me a second, sir.
Okay. Correct. So before, let's give some time for Arudit, let him prepare. So before that, I'll explain to you all how this protostars gas pressure and this gravity becomes equal to each other, right? So that is a question, right? Sometimes if we say, okay, there is a protostar and this protostar's gravity and this protostar's gas pressure, they are becoming equal to each other. Some person can ask the question, how does it become equal to each other? Why are you saying that it's becoming equal to each other, right? So for that, we need to give an answer. We need to know why it is becoming equal. So how does it become equal, right? So I'll give you yeah.
Excuse
Arudit is
me,
there.
sir.
Yes. Yes, go ahead, Arudit.
When the sun, when the photostar became the sun and
Yeah.
released the asteroid, then the asteroids contain of some magnetic areas which crashed and became sand. So that means sand has magnetic parts as well.
Yeah. Even I'll
I have some magnets and all the sand, some sand was attractive.
magnetic.
Even some rocks that look
That's true.
perfectly normal.
That's true. Thank you for highlighting that, Arudit. Thank you for that so much. And actually, not only sand, even if you take humans, right? So Arudit is a human. I am a human. Imalka is a human. Like that, all of us over here are humans. We are also basically stardust. You know that we were once stars. We are this because we came from Earth, right? So Earth is basically made up of, like how I explained to you, there was a red giant. That red giant exploded, and the particles from that red giant is what how a nebula in the nebula a protostar came into existence. From the protostar, our sun came into existence. Like that, the planets also came into existence. Just like that, everything in this planet is also stardust. So even humans are stardust. We also have elements in our body. That's the reason why when you can even go and take a blood test or anything, and you can see we have iron in our body, we have gold in our body, we have copper in our body, like that. All these elements, hydrogen is there in our
We
body.
have elements
Everything.
like copper and iron.
Exactly, yeah. Do
Even
you know,
diamond?
Arudit? Do you no, diamond is not there. Diamond is not an element.
Excuse
Do
me,
you know?
sir.
Yeah, Arudit,
Excuse
do you know that in our body we have gold? Do you know that, Arudit?
No.
I
Yes.
know, sir.
Where
I know it, sir.
Imalka knows it. Super. So we
Did
have
you
gold
know,
in our body.
sir, did you know we have gallium in our bodies?
Yeah, most of the elements are there. Most of the elements are
most of
there.
the star elements is in our body, you mean? Most of
Yeah,
the star
guys, one at a time.
elements,
One at a time. Yes. Yeah, Arudit, go ahead.
it means that there can be hydrogen and helium too, some little drops.
Yes, yes. All these elements only make up
Are
our
there
body.
metal
That's how we are.
Are there metallic things as well? Metal like things?
Yeah. But it's not like how you said, like, you know, when you took a magnet outside and the sand was attracting to the magnet. But for humans, there is no very huge effect, but there is. Yes, Bina, yes, go ahead.
Do we have carbon dioxide in our body?
Yeah, we are actually exhaling it out, right? We are breathing in oxygen, we are exhaling it. Carbon dioxide.
Excuse me,
Yes.
sir.
Yes,
When
Arvind.
plants breathe in carbon dioxide, they breathe out oxygen. And when we breathe oxygen, we release carbon dioxide.
Super. All right. Okay. So now we'll pause answering questions.
Carbon dioxide, it's bad.
Yeah. Obviously, it's bad. Nothing. We should have anything. Everything should be in the same level.
It's called air pollution, and it can make us cough. And fire is the best thing to make it. Fire and power plants.
All right. Okay. So now we'll move on to our next part because I think we are running out of time. We have only just 2 hours more, so we have to cover this up really quick. Okay. So right. So now, how did this gravity and this gas pressure become equal? How did they become into equal? So now I'll explain to you how they became equal. All right. So first, basically, I explained how these gas and dust particles were pulled towards the core, right, of this star, of this protostar. So protostar is a prospective star, which is supposed to become a star in the future. So this gas and dust particles which were pulled towards the core of the star, they start heating up. Their temperature starts increasing. This temperature increases. And just like how I explained, in our human body, we have elements, right? So what are these elements? Oxygen, iron, gold, copper, silver, mercury, like that. There are so many elements, right? So like that, what happens is this temperature increases. And yes, and there is something called atoms, right? So just I'll give you all a small idea about what atom is. I'm not going to explain in details about what atom. Yes, Sudhita.
Excuse me, sir.
Yeah,
Excuse
guys.
me, sir. I
Guys,
know
just
what the atom mean. It also
Yes,
contains
super.
electrons. It also
Protons,
contains
neutrons.
electrons. And those makes electricity.
Yes.
Electricity
Guys,
contains of many protons and electrons.
Yes, guys. Okay, guys, just give me some time. Okay, after explaining, I'll give you all a chance to speak. All right. So now I'll cover this up first, because if I don't, it will be a problem. So after I finish, I'll definitely give you all time to speak, like how I promised you. Okay, I promised you all that I'll give you all time. So don't worry, I'll definitely give you all time to speak. Okay, so now first I'll explain this. So the temperature increased tremendously. It increased so much that you can't even imagine how hot it is. It became so much hot. We all know that the core is definitely hot. Even Earth's core is very hot. So just like that, the sun's core is very hot as well, right? So the temperature kept increasing. And there are some things called atoms. So what are these atoms? So I'm not going to go into detail. Like Arudit explained it really well. He was like, there's neutron, there's electron. Even electricity works because of you can only understand Yes, yes. Sudipta, just give me some time. I'll explain and then I'll give you a chance to speak. All right. Okay. So this atom is basically, we call it as the building block of anything, right? So every single thing that you see in this world, humans, animals, lion, phone, camera, cap, t-shirt, water, every single thing that is there is made up of atom. Even this earth is made up of atom. Even the sun is made up of atom. Every single thing is made up of atom.
Our body is made of atoms.
Yes, so these atoms are really tiny particles which you can't even see using your naked eye. So if you just see like this, you can't see these atoms. You need to have microscopes to see these atoms.
Even if you see them, everyone and everything look like monsters.
Yes, yes. So yes, so just give me some time. Yeah,
And we can't see from the microscope.
Sir,
superb. Yes. Yeah. So
excuse me, sir.
yes, Simalka. Yes.
The gravity and heat are not actually equal because but you can
Not
say
heat.
they are equal.
It's the gas. It's the gas pressure. You see, when the heat increases, the gas pressure also increases. And so the
They
gas
are-
pressure and the gravity, yeah, they achieved
Yes, sir.
a state of equilibrium. So what basically happened was they achieved a state of equilibrium where the gas pressure and the gravity, they became almost equal. And then what happened was they, from a protostar, they actually became into a star, like how our star sun came into existence. So now I'll just explain to you how it became equal, right? So now first how it became equal is, like I said, the core, right? The core became really hot. The temperature was increasing so much, and everything is made out of atoms, like how I explained. So even the core is made up of atoms. So in our star, the sun has, what are the elements that are there in our sun? That is hydrogen and helium. So these hydrogen and helium, the atoms started colliding. The collisions increased. So that means one atom and another atom started, attacking each other. Attacking in the sense, knocking with each other. They started attracting, knocking. This became so much. This increased so much, rising the gas pressure, and the temperature also increased automatically. And then what happened was, finally the gas pressure and the gravity, they became equal. So that is what the scientists are saying. This is what happened in order for the star to achieve equilibrium. So this is how the gas pressure and the gravity of a star became equal to each other. So how did it become equal? The core was there. The core is made out of atoms. These atoms collided with each other. The temperature increased. Due to these collisions, the gas pressure also increased. And with the gas pressure, and this gravity, they became equal to each other. Right? Okay, perfect. So that's how a protostar became into a star, right? Okay, so now let's see what is there. Now let's see the birth of our star. So how did this star came into existence? So now we saw how the protostar's equilibrium formed, how the equilibrium came into existence. Now let's see how the birth of the star is, right? So let's see how it is. So I think you all would have already known about many types of stars, right? Red giant, white dwarfs, like that, neutron star, like that. There are many
There are
different
thousands of
types.
stars.
Yes,
Even
so like,
types of them.
yes.
And there are quark stars and even so many stars. Even black
Yes.
holes are a type of star, but they spin too fast.
Stars. Black holes are dead stars.
Black holes are still stars, but they spin fast. So light don't escape.
one time.
Excuse me, sir. Excuse
Yes,
me,
yes.
sir.
One at a time. Yeah.
Excuse me, sir. When
Yes.
star square, when the white dwarf dies, it actually only spins faster. And then light starts exit. It doesn't exit anymore. The reason is because it spins super fast. So light can't escape, but actually there are light left inside, just fireballs and so many lava and
Okay.
plasma. That's why anything that comes.
Little by little, the black holes get bigger and sucks lots of things once nearby.
And
So
even
don't worry, guys. Black holes.
Even at the end of the.
Yes, sir. Yes, sir. So black hole.
Even-
Don't worry, guys. Don't discuss. We'll stop discussing about the black hole now because today is about solar system. Don't worry. There is a special day for black holes. Yeah, we will talk everything about black holes. Today is all about solar system because the thing why I'm telling you all not to discuss about the black hole is because if we go into those parts of astronomy, we won't be able to cover these parts of astronomy. So today's day is specially covered, like how I showed you all also. We are talking about the formation of our solar system, our star, the sun, planets and their moons, identify the location of Earth and the reasons as to why it is located there, and we're going to talk about eclipse as well. So this is all the things that I'm going to cover today. So if we talk about other stuff, we won't be able to cover this up. So first what we will do is we'll first learn what are these and we'll understand these things in details, and then later on, like how I said, I'll give a chance for each and every one of y'all. We can discuss together as a group and then, come up with ideas. All right. So now we'll come back to formation of our solar system and let's see what else is there for us to learn. All right. Okay. So now I explained about how a protostar achieved its equilibrium, right? So the core becomes really hot, the pressure increased, and the pressure increased to a certain limit where, the gravity and the pressure, they achieved equilibrium. So once they achieve equilibrium, that's when a protostar becomes into a star. So now when it is becoming into a star, there is actually two things that can happen, right? So there's two things that can happen. One thing is that when the star has very less weight, right? So mass, so you call mass, right? So mass and weight. So I'll just keep it as weight because that's what we all are familiar with, right? So when the mass of the what do you call, the star is not not too much, I mean, if it's less, what happens is it becomes a brown dwarf. Okay, so we'll see what this brown dwarfs when we talk about stars. Okay, so now I don't want to go into details about what brown dwarf is. Don't worry, I will definitely explain to you all what brown dwarf is during the group discussion as well as when we talk about stars. Don't worry. Okay, you can note this down and keep it. So it becomes into a brown dwarf. Why does it become into a brown dwarf? Because it has very less weight. Okay, so whenever it has very less weight, this protostar becomes into a brown dwarf star. So what is this brown dwarf star? This brown dwarf star will not be able to radiate heat and light. What does that mean? So if you have a brown dwarf star, it will not give out light. It will not give out heat like how our sun is giving out. So our sun, when you go and look out, when you go out of the house and when you look at the sun, you can see that the sun is giving out heat, right? That's why our body is becoming hot. At the same time, the sun is also producing light. That's the reason why in the daytime when you go out, you don't need torch light or anything, because the sun's light is more than enough. It is illuminating the entire world, right? The entire world is lightened up by the sun's light. So that is the first thing that can happen if this from a protostar. Well, what is the second thing? In the second thing, if the mass, right, the weight of the star is more, if the weight of the star is less, it becomes into a brown dwarf. But if the weight of the star is more, what happens? Then what happens is nuclear fusion begins. What is this nuclear fusion? Now, nuclear fusion, I'll explain to you. Don't worry, I'll explain. Arudit gave a really good answer when we started today's class. Right, so already just slightly he gave an answer about what nuclear fusion is. Now I'll explain what nuclear fusion is in detail, right? So nuclear fusion actually it's a very big topic, right? It's a very huge topic where there is a lot of discussions to be made, but I'll just give you all a rough idea. Remember, I explained to you about the elements that are there, right? How I told you in our human body we have hydrogen, we have helium, like that we have all these elements. So just like that, even our star has elements in it. Earth has elements in it. Mercury has elements in it. Like that, all the things have elements in it. All these things are made out of elements, right? So just like that, the sun also has elements. What are the two elements? Hydrogen and helium, right? So these hydrogen and helium, what happens is nuclear fusion takes place. So what is this nuclear fusion? Nuclear fusion is nothing but atoms fusing together, right? So these atoms, they fuse together and they form newer elements, lighter elements becoming denser elements, right? So now when I explain, some of you all might not understand what I'm trying to say, but just remember that nuclear fusion is nothing but an element changing itself to become another element. That's like the basic idea of it. Okay, so an element changing itself to become a different element. So this when this nuclear fusion takes place, a very huge energy releases, an energy which you can't even imagine. It's really huge. The impact, the what you call the outcome of this energy is unimaginable. That's how much of energy that is released from this nuclear fusion. Just to give you all a rough idea about this nuclear fusion, I'll tell you about a small story. Have you all heard about Hiroshima, Japan? Guys, I'm asking you all a question. Now you all can speak.
Yes, you mean the bomb, right?
The bomb, right? The Hiroshima Nagasaki bombing, right? Which happened in World War II. So that was not just an ordinary bombing, right? What kind of bomb did they use?
Nuclear bomb, like an atom bomb?
An atom bomb. Exactly. It was an atom bomb, right? So even there, something similar took place. So that's the reason why the energy that was released from this bomb was extraordinary. It was destructible. Like, you know, whatever is there in its way will get eliminated. It's unimaginable, the amount of energy that can be carried. Yes, go ahead.
Sir.
Yeah.
In that bomb, there was energy. Even we can't think about that energy.
Yeah, it's not a very less amount, you know, it's a very, very, very huge amount. Super huge amount. That's the reason why these, I told you about this Hiroshima Nagasaki thing. So that Hiroshima Nagasaki bomb, what happened was it released a very huge amount. I think who told me? Chirat knows about it. I guess some of you all might not know about it. So I'll just show you how this nuclear bomb. Have you heard about something called the nuclear bomb?
I have heard about it.
You all have heard about it, right? I'll just show how much of, you know, energy is released from that. Okay, there are videos in YouTube. I'll just show just a simple video. It won't take much long. I'll just show you how much of energy is released from that. And the reason why I'm showing it to you all is just to give you all an idea. Now these nuclear bombs that these people are making in this earth, the one they used in Hiroshima, Japan, is nothing compared to the energy that is released in the sun. The energy that is released in the sun is like million times more than millions and so many times more than that. Okay, so just imagine how much great the energy is there in the sun, right? So this thing which is not even a fraction of that energy is causing so much of destruction. Then just imagine how much of destructions and chaos that the sun can create, right? You all can just, you know, imagine of it. So I'll just share my screen and I'll show you how this nuclear bomb releases its energy. Yeah. Guys, can you see the screen? Can you see the screen?
Yes.
Hello, guys.
Yes, sir.
All right. Okay, I'll go and play this. Let me fast forward.
Yeah, but what's the name of the bomb?
Tsar bomber. I think it's Tsar bomber, I guess. Let's see.
It's the most powerful bomb that ever exploded.
Yeah, Tsar bomber is the most powerful. This is not Tsar bomber. I think this is something else. This is made by the US. You can, you know, just once the class is done, you can go to YouTube and research about it. Yes. Okay. Arudit, are you here with us? Hello, Arudit.
Yes, sir.
You saw that, no, Arudit? Why is your screen, your camera switched off?
Yes, sir. I have no power.
No power?
I have low power in the computer.
Right. Okay, no worries. You can hear, right, what I'm explaining? You can see
Yes,
the
sir.
screen and stuff now? Okay,
Yes.
okay, super, super. Okay, you could pay attention. Okay, so if there's anything, just let me know. I guess all of you. Shanuli, what about you, Shanuli? Hello. Okay, all right. Okay, no worries. Yes, so that's what happens. So that's basically what nuclear fusion is about. Okay, so that's nuclear fusion took place in our protostar. Protostar in the sense our sun. That's the reason why today our sun is able to produce heat and produce light. Understood? Right. Okay. And that is basically the formation of our solar system, right? Okay. So now next we have in our agenda is our star, the sun, right? So I'm going to explain about our sun. Now, before I explain about our sun, I'm definitely sure that most of y'all over here are always ready to answer, give answers. Y'all will already know more about the sun. So if anyone is interested, I'll give one by one chance. Everyone don't unmute and start speaking, because if y'all do that, it's very hard to, understand. So first, who wants to go first?
Sir, I'm
Arudit. Can you explain about the sun? What do you know about the sun?
the
Our
sun has nuclear fusion
Okay. What else?
and it has trillions of planets which release light particles which make the light, and light particles travel in a really high speed, and the sun has a high gravity, and the sun releases radiation and some cosmic rays.
Yes.
And,
Thank you, Arudit.
and
Okay, next.
the sun's radiation is blocked from the ozone layer in the Earth's atmosphere.
All right. Okay. Thank you, Arudit. Next, Imalka wanted to go. Imalka, your chance.
Our sun has 2% of hydrogen and 2% of helium, and the other 96% is other stuff like methane and water vapor like stuff. And our sun makes up 99.98% of our solar system. Our planets our planets make up 1.1% of our sun.
So basically,
Our solar system.
one at a time. Imalka, are you done?
Excuse me, sir.
Yeah.
And
Finish, no?
the sun's gravitational field is so powerful that it ends in 6 astronomical units away. It can stretch about 6 astronomical units or more from the galactic center.
Yeah. So basically, till the Earth cloud distance, right? So it's a very huge
Excuse me,
distance.
sir.
Yes.
And
Yes, Bina.
The sun
Yes, Bina.
gives some oxygen to Earth for some people to live, and it has lots of kinds of things in the sun, and it has some layers.
Okay. So different people are saying different. Can I say?
I have not explained over it.
All right. Okay. Yes, Imalka, go ahead.
And they are because of the sun's power and energy, if we bring all the energy of our sun to Earth, our Earth, not only our Earth but Mars and Mars would explode too because of the fusion reaction. Earth,
Exactly.
the moon, and the Mars would explode.
Exactly. Thank you, Imalka. All right. I think Tisen is also was trying to explain for a long time. Yes, Tisen, go ahead. It's your chance.
The sun is the star at the center of the solar system. It is a nearly perfect ball of hot plasma heated to essence by reactions in its core radiating the energy mainly as visible light, ultraviolet light, and infrared radiation. It is by far the most important source of energy for life on Earth. It is a diameter about 1.39 million kilometers, 864,000 miles.
That's true. That's actually a really good point that Design pointed out, is that the sun's diameter, right? The sun's diameter, that in the sense how thick the sun is. So you can basically keep 100 Earths to the size of the sun. So for example, if we say, now I'll take my phone, really just, I know this is not the sun, but if this is the sun, okay? So if this is the sun, you can see the phone, I think, yeah, you can see the phone, right? So if this is the sun, I can keep 100 Earths. So 1 Earth, 2 Earth, 3 Earth, 4 Earth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, till 100 I can keep like that. So that is also another fact. Just listen. So what else you have to explain? Thank you for mentioning that thing. So I remember it. Yeah.
9 times that of the Earth. Its mass is about 330,000 times that of Earth, and it accounts for 99.86% of the total mass of the solar system. Roughly, the quarters of the sun's mass consist of hydrogen 73%. The rest is mostly helium. 25%, with sun's mass consists much smaller quantities of heavier elements, including oxygen, carbon.
Okay. Thank you for your attempt, Tisan. Thank you for your attempt. I think Chirath has also raised his hand. I guess he also think it's better if we give him a chance as well. Chirath, do you want to share some
The
ideas?
sun is the star. There are many stars in the universe, so the sun is just one medium-sized star. It's in the center of our solar system. It's what we see in the sky every day. It's actually pretty huge. So it was made by a nebula about 4.6 billion years ago, and what basically happened is that there was this gravitational disbalance. Like, it's not balanced. In some places, the material is denser than the other, so the denser bits come together because of gravity, and they circle around each other. Then they come and sort of fuse. Then the protostar is born, and after a time, that protostar also gains mass, and as it gains mass, it also gains more gravity, because it's attracting all the stuff around it, and all this stuff sort of accumulates around it to form something called an accretion disk, I think.
Yeah, that's right.
And after so much material gets pulled in, that the star becomes so big that nuclear fusion erupts. So the sun jumps from protostar straight to just an ordinary star. So by nuclear fusion, you mean in something like two atoms that are fusing together. And I've heard that if nuclear fusion is not there, the star would collapse, because it's so huge and has so much gravity that if the energy from nuclear fusion is not keeping it sort of blown up, the gravity will pull it in, and that's how the star dies, basically, I think. And that's it.
All right, okay. So basically, that is also a really good point that Chirath highlighted, is that you see now when you take our sun, the sun has one of the most the lightest elements in it, right? So hydrogen, helium. So hydrogen has like around 88%, 87%, somewhere around that part, and then helium is remaining 10%. So these are very light elements. So what basically happens is that these lighter elements, not only our sun, basically any star, what basically happens is when it's going to die, right? So when it's the stage of dying, these nuclear fusions take place, and then these elements start changing. So they become uh, what you call as more heavier elements like iron, like yeah, the fusion takes place like that, and if these elements changes.
Gold, all of that.
Yes, exactly. So it becomes an iron, and then finally that's when the you know the star is unable to form any more elements, and it stops, like it ceases to exist. Yes, Sudhita.
The sun is the center of our solar system, and the sun was born in 4.6 billion years ago, and first gas gathered and made the sun, and then after that accretional heat rounded the sun, and then and big chunks of rock were floating, and then the terrestrial planet came from rock. The rock collided, and then became a sphere.
All right.
And
This one, yeah. Yes, Sudhita. Yes.
and Jovian planet happened when the gas and the leftover gas and dust came to center and made Jupiter, Saturn, Uranus, and Neptune. The sun is a yellow dwarf star, and when hydrogen and helium fuse together, the nuclear reaction comes, and when too much nuclear reaction comes, spheres of plasma come like this, and then Kepler is also exposed in the sun, and there is something I don't know that I did not study.
No worries.
And still Parker Solar doesn't know what happens, and still nobody knows why the sun happened like this. But one theory is that in the sun, when waves come like this, they make plasma too.
All right, Sudhita. All right. Thank you for that. I think Thyssen has something else to share as well. Thyssen? Hello?
Yeah, sir.
Yeah, you got anything to share with us? Do you have anything else that you want to talk about? The sun or anything? No. All right. So all good, right? So I gave chances for everyone to speak.
Sir,
Yes.
I
Yes.
have something to tell about space and how a solar system works.
Yeah. Imalka, before you go, is that related to the sun or is it something else?
Both.
Both. All right. So perfect. So before we go to that, I think we are done 1.5. So we have another 1.5 hours more. So 1.5 hours is covered. 1.5 hours to go. So I'll just give you all a 10 minutes break. So if you all want to go to the washroom, drink water, do anything, you can do it within the 10 minutes and come back again. All right. Perfect. So just 10 minutes. Okay. So don't take much of your time. So another 10 minutes, I'll start. All right. So soon go get refreshed and come back. Okay. See you.
Excuse me, sir. Excuse me, sir.
Children's songs, sing and move along. Children's songs, make your brain and body strong. Countdown to blast off. Countdown to blast off. Mission control to astronauts. Space travel check. Astronauts ready? Check. 1. Space helmets on. 2. Space boots on. Zap, zap. 3. Safety gloves on. 4. Space belts locked. Click, click. 5. Space ice cream taste. Chocolate. Astronauts, take one big step to the spacecraft elevator. Going up. Level 1, 2, 3, 4, 5. We're going higher and higher. 6, 7, 8, 9, 10. We made it to the top. Now sit down in your spacecraft chair, lock in, and ready for countdown to blast off. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off! If you like this video, be sure to give it a thumbs up and leave me a comment below. For lots of great songs on basic math skills, check out my album, Math All Around Me, on my website, jackhartman.com. Click on any of the video boxes to see more fun educational videos. Also, visit jackhartman.com, like my page on Facebook, and follow me on Pinterest. And remember, click on subscribe to get updates on new videos as I add them to my YouTube channel. Children's songs, sing and move along. Children's songs, make your brain and body strong. Countdown to blast off. Countdown to blast off. Mission control to astronauts. Space travel check. Astronauts ready? Check. 1. Space helmets on. 2. Space boots on. Zap, zap. 3. Safety gloves on. 4. Space belts locked. Click, click. 5. Space ice cream taste. Chocolate. Astronauts, take one big step to the spacecraft elevator. Going up. Level 1, 2, 3, 4, 5. We're going higher and higher. 6, 7, 8, 9, 10. We made it to the top. Now sit down in your spacecraft chair, lock in, and ready for countdown to blast off. 10, 9, 8, 7, 6, 5, 4, 3, 2, If you like this video, be sure to give it a thumbs up and leave me a comment.
Hi kids! You know, we're using our imaginations and playing
Hello guys. Hello. Hello. Are you all back?
Hello, sir. Hello,
All
sir.
right. Are you ready?
Yes, teacher. Yes, sir. Yes,
Okay. Perfect. Okay. So I think before we went on a break, Imalka had something to share with us. I told him to wait for some time. Imalka, now it's the perfect time for you. You can share now. If you don't
Any solar system has to have a star in the middle of the system, or else all the planets will float into outer space. If we move our sun, it is no problem, because we also follow the sun, and we have a full chance of survival. If when in the future our sun will turn into a red giant and swallow all the inner planets, and hour or so later it will shrink into a white dwarf, and when it starts to fade away, it will be a black dwarf. When black dwarf die, it will be nothingness.
But actually,
All
black dwarf
stars,
something which is not yet what do you call documented by most of the scientists, because they are saying just because there's a white dwarf, that there is a possibility that a black dwarf can also exist, but actually still it has not been documented. So it will be a
yes,
really phenomenal thing if people,
our solar
yeah,
system is not old. Our universe is not old enough to
yes,
exist black dwarfs.
exactly.
That's why we can't observe black dwarfs.
So true.
And
All right. Yeah.
when all stars die, black holes.
Yes, Binal. Yes.
The Earth has a thing what's inside the Earth is the moon. The moon stays the Earth in one side because the moon spins around the Earth. So, and the moon keeps the Earth steady from moving and floating away.
Yeah, partial. Yeah.
If
Who
we
was
go
that?
to the if we go to the past and
Yeah.
see the nebula, and we remove the dying stars and put it for another million or so years, it won't be a star anymore. It will be a nebula forever. and we won't exist because of the supernovas around the nebula. That's why our sun became a protostar and became the real deal.
All right. Okay.
Excuse me,
Okay.
sir.
Thank you. Yeah. Yes,
If
Bina.
that time the nebula was blasted, if a big rock burst, when one day in Australia there's a big hole, what a space rock crashed into Australia once.
Okay.
I made a hole.
Hole in the sense you call it as a crater.
Yeah, crater, big crater.
Yeah. All right. All
Just
right. Okay.
million years ago happened. If that time the sun was there.
Yes.
And
Okay, kids. So yeah. Imalka, like one more second.
And
Like you
the
can
sun
pause again. Yeah.
and the sun is hot, but it doesn't have any volcanoes inside the sun. It only have lava. It affects so much light.
Okay, guys. Okay. So first, now we discussed about the formation of our solar system, what the sun is, and then you all gave us your understanding about how the sun was formed and what the sun is and what's the functionality of a sun and all of that. Super well done. So now there's something else in today's agenda that we'll have to look into it. So we'll look into that first, and then we'll discuss about that in detail. And then once that is completed, then again I'll give you all the chance for you all to discuss about the planets and their moons. Okay, so next what we have today is about uh, the planets and their moons. Okay, so what is a planet and their moons? So basically most of the planets in our solar system, right, not everything, most of them have their own natural satellite. So what does this natural satellite mean? Okay, so there's this term satellite basically means something which is in orbit of a celestial body. Yeah, Arudit, just give me 10 minutes. Arudit, give me 10 minutes. I'll give you the chance to speak. Okay, next Arudit Toli will speak. I'll give you the chance. Okay, Arudit. Okay.
Okay, sir.
All right, super. Just give me 10 minutes. Okay, so I'll finish this and then the next person is Arudit. Okay, awesome. All right, so then every celestial body, not all the celestial body, most of the celestial bodies have a satellite of their own. So when it comes to satellite, we can term them as natural satellites as well as artificial satellites. So when you take planet Earth has both natural satellite and an artificial satellite. So what is the natural satellite that planet Earth has? That is moon, right? So moon is the name. Yes, so moon is the name that we have given for our natural satellite. So what are
scientists call it lunar.
Yes. So artificial satellites, there are so many satellites. So Chinese have their satellites, the US have their satellites, so many satellites are there. So those are man-made satellites, what we call as artificial satellites. So now let's look at a graph which I found in the online. So it's from the NASA website itself, which gives us a documented, what do you call, a representation of how many satellites do each planets in our solar system have, and how many satellites from these planets are. Yes, Arudit, I told you. Just give me 10 minutes. I'll give you the chance to speak. All right. Once I finish this topic, again, I'll give you all the discussion part so you all can start discussing. Okay. Just excuse me for 10 minutes. So I'll just show you all a small diagram about the documented satellites of the planets in our solar system, the ones which have been documented and the ones which are currently documented in order to clarify if it's a satellite or not. Okay, so now let me share the screen. So where's the screen? Yes, this is the screen. Okay, so here, so this is, as you can see, this is the NASA's website. So you all can also go and look into this website, which I will be sharing. I have the notes as well prepared with me of today's lesson. So I'll be sharing today's lessons note. I will also be sharing this plan as well, astronomy camp plan with y'all, so that y'all can refer that. So the notes, the astronomy camp plan, as well as the videos that I showed you on YouTube, I will be sharing those links and these links as well, so that later on when you are more interested, you all can go through this, and if you all have any questions, any doubts, you all can always come and ask from us. Okay, so this is just a representation of how many moons does each planet have. So here we are discussing about the planets that are there in our solar system. All right. So like I said, not all planets have their satellites, right? So Mercury doesn't have a satellite. Venus doesn't have its satellite. So does that mean that these doesn't have artificial satellites? No, it doesn't have natural satellites, but man-made artificial satellites are there, right? So which are currently monitoring these planets. So Earth has one satellite. Mars has two satellites. Jupiter has 79 satellites. Now next to this 79, they have mentioned 53 confirmed and 26 provisional. What do they mean by this? What they basically mean is that 53 are confirmed. So that means scientists have confirmed that planet Jupiter has 53 natural satellites, just like how Earth has one satellite, which is called the moon. So just like that, they are saying that 53 satellites or 53 moons have been confirmed that Jupiter has. Apart from those 53, there are another 26 which scientists are still researching on. Scientists are still studying it about. They haven't given a name for these 26 satellites. Later on in future, once they have fully studied about these 26 provisional satellites, once they have fully understood about these 26, then they will give them names and then they will confirm it. But as of now, as of today, 2nd of January 2022, they haven't confirmed any of it. So next we have Saturn. So Saturn has 82 satellites of its own, whereas 53 is confirmed, just like Jupiter, and 29 is provisional, in the sense which is not yet confirmed. Uranus has 27, Neptune has 40. So now I'll show you what it basically means. So now here they are just showing you the total. So 0, Mercury doesn't have a confirmed moon. It also doesn't have a provisional moon. So what does that mean? Any celestial object which is orbiting Mercury, which can be identified as a moon, there's nothing like that. Okay, so there's nothing orbiting Mercury, just only small asteroids and meteors. That's it, which cannot be termed as a moon. So that's why the total is 0. So Venus also, the total is 0. Earth also, it's 1. Mars has 2. Jupiter 79. Saturn 82. Uranus 27. Neptune 14. And these are the dwarf planets. Pluto. So now this dwarf planets. About dwarf planets, I will be explaining it the next week class. Okay, so where's the next week class? So now when you go here, for week 1, I have explained. So now I'm explaining about planet and their moons. Next, I have the identified location of Earth and the eclipse, which I'll be explaining in a short while. Now, in the second week, solar system part 2, this is where I will explain about the dwarf planets. So you don't have to worry about dwarf planets. I'll definitely explain it. So that's on next week Sunday. That's in our next week Sunday criteria. Yes, just give me 5 minutes. Okay, I'll finish this up and then I'll give you all the chance to speak. So for dwarf planets, we have Pluto. So for Pluto, there are 5 moons or 5 natural satellites which have been proven and confirmed, but there is no other provisional satellites for Pluto. That's the reason why the total is 5. Okay, so that is basically it. So now I had many people asking me questions. So starting up first, I promised. So Arudit, you can go ahead. Arudit, over to you.
Excuse me, sir.
Yes.
The natural Saturn means even galaxies have some. Andromeda galaxy has a Saturn galaxy. Its name is Triangulum galaxy.
No, those are called satellite galaxies. I'm talking about satellite celestial bodies that are orbiting planets. Those I will talk about when I'm talking about galaxies, Arudit. So there is a special day where I will be talking about galaxies. I'll show you, that is over here. When I go week 2, week 3, week 4, so that is next month, I guess. Yeah, the second month of our camp, we'll be talking about galaxies. So over there, I will talk about what Arudit was explaining. Okay, Arudit.
Excuse me,
So
sir.
I hope you understood. Yes, Himalka, yes, go ahead.
The reason Mercury and Venus doesn't have a natural satellite is because of the distance of them. Because they are too close to the sun. There is a theory that Mercury had a satellite 4.2 billion years ago. So I actually don't know.
Yes,
And
it crashed.
but it had crashed into the sun. And that means the further you are away from the sun, the better chance that you have a satellite.
Exactly. Thank you for sharing that as well. All right, so that is basically about the natural satellites that are there in the planets in our solar system. All right, so I explained, and also Imalka and Arudit gave their views about it. So that's basically it. And next we have in our agenda about why the Earth is situated where it is situated. So in the example, we have 8 main planets in our solar system, right? So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Why is Earth the 3rd planet in our solar system? Why can't it be the 4th planet? Why can't it be the 2nd planet? Why didn't it be the 1st planet? There is a reason behind it. Now, the reason I will be explaining it for you shortly, but there is someone over here who. Yes.
Habitable zone.
Yes.
Because of the
habitable zone means place where it's not so cold or not so hot.
Yes, one at a time. Hold on. Yes. Next is Binal. 1 second. I think Chirat wanted to speak. He didn't get the chance. Yes, Chirat, go ahead.
Earth is sort of here because, like, in the place that it is today, because of the interactions of Jupiter and all the other large and other smaller planets, and also of the moon, so that it pulls it into a certain orbit around the sun.
But we can see the name.
Okay, I think Binal wanted to speak next. Binal.
If it was the first planet, the habitats in Earth will die because it's so hot.
So there are plenty of reasons as to why Earth is located where it is located.
I am Sudita. I want to speak.
Yes, Sudita, go ahead. Sorry, yeah.
Now the habitable zone is a zone where a planet can stay. If it's too near to the sun, it won't be habitable. And if it stays in near Mars side, it will be too cold, and seasons will be dramatically changed. And the habitable zone is the zone that only planets can stay. If our sun was small, if it was a dwarf star, the habitable zone will be near.
Yes.
If it's a medium sized star, it will be a little much far.
All
And
right.
if it's a red giant, it will be very, very far. The habitable zone.
Okay, thank you, Sudita. Thank you for that. Okay, so now let's see why the Earth is located where it is now. Okay, so basically there are many reasons. Now you all have basically all 4 of you all, Imalka, Arudit, Bina, Sudita, Chirat, you all shared your ideas, whatever you all have learned about. All of them are right. So they all play a role as to why Earth is located as the 3rd planet in our solar system. So it's basically due to various reasons. All right, so it doesn't necessarily have to be why Earth is located in the 3rd position. It is basically why Earth is sustaining life, right? So when you take all the planets in our solar system, not all the planets have life in it. And even if you take the natural satellites, not all the natural satellites sustain life. Even our moon does not have any life in the moon, right? So there's only life in one planet, one celestial body, and that is Earth. So that is the first thing that we need to pay attention to. So the location of Earth is actually, like I think Sudita mentioned, they say the habitable zone. Rather than mentioning it as a habitable zone, there is actually a scientific name for that. We call it as the Goldilocks zone, right? So the Goldilocks zone is where any planet, right? It doesn't have to be Earth. It can. Yes, yes, Sudipta. Yes, Imarka, just give me 5 minutes. I'll give you the chance.
Goldilocks planet.
Yes, Sudipta. Yes, Sudipta. Thank you. Okay, I'll give you the chance to speak. Okay, so now, so they call this habitable zone as the Goldilocks zone, right? So the Goldilocks zone is not only present in our solar system, it is basically there in most of the solar system. So now you might have heard about the James Webb Telescope, right, which was launched last month in December.
I have heard about the James Webb Telescope.
Exactly. So now this James Webb Telescope is a highly sophisticated and yes, Chirag. So highly sophisticated and highly advanced telescope which was put into the outer space, right? So one of the duties of this what do you call this telescope is to find life beyond our solar system, find life in other parts of our galaxies. So how does this James Webb Telescope identify life? Where will it go and search? Now, for example, okay, so just to give you an example, if I say the term shop, it can mean a lot of things. It can be a clothes shop, it can be a food shop, it can be a car shop, it can be a book shop. Like that, there are so many shops in this world. Now, if I tell you to go and buy clothes, what kind of shops will you go looking for? You'll go looking for textile shops, right? Shops which sell clothes, right? You won't go for a bookshop searching for clothes. Will you do that? You won't, right? So you won't go to let's say, will you go to McDonald's in order to buy books for your school? Right? No one will do that, right? Have you all ever bought books from McDonald's?
No.
No, right? So have you all bought what do you call
Never. We can't study from burgers.
Exactly, right? So you all basically know where to find the suitable thing from which location. So just like that, James Webb Telescope is put into space to find life beyond our solar system, in other solar system and other what do you call, other galaxies. Even in our galaxies, it is basically finding life. But how will it know where to find the life? Where is the life located? Yes, Sudhita, give me 5 minutes. I'll give you the time to talk. So, yes, Sudhita, just 5 minutes. Yes, 5 minutes. Yeah. Yes. So the James Webb Telescope basically aims at the habitable zone, or the Goldilocks zone of all the stellar systems that are there in our galaxy. It only focuses on the Goldilocks zone. It doesn't focus on the other two zones which are present. It only focuses on the Goldilocks zone, because Goldilocks zone is the only zone which is preferable to sustain life. And that is the very reason why Earth itself has life in it. Now, there are scientists are still have found that they have sent the Mars rover, right? So to Mars, so we are exploring Mars and we are discovering stuff in Mars. Even now, at this very moment, we are having this class. There are space probes which are, doing researches on Mars. And what we have found is that Mars used to be a water planet, just like Earth. Now, when you look at the planets, the four rocky planets, we know. Yes, Arudit, I'll give you the chance to speak. I'll give all of you all a chance to speak, especially Imalka. Imalka has been raising his hand for more than 15 minutes. I think Imalka's hand is also might be paining. Don't worry, Imalka, I'll give you the chance to speak. All right, perfect. So now I'll just explain. So we have these four rocky planets: Mercury, Venus, Earth, Mars. So from that we know Venus is one of the hottest. It is the hottest planet in our solar system, right? It is sometimes called as the fire planet, whereas Earth is called as the water planet. So the location of the Earth, since Earth is located in the Goldilocks zone, Earth can sustain liquid water. And we all know that wherever there is water, there can be life. And that's the reason why Earth is the third planet and why Earth is the only planet which can sustain life. Okay, so now starting off, we have first Imalka, who wanted to speak for a very long time. We'll give Imalka the chance. After Imalka, it is Sudhita. After Sudhita, it is Arudit. After Arudit, it is Binal. Okay. So Binal, you're fourth. Imalka first. Sudhita second. Arudit third. Imalka, up to you.
Our Earth is located 93 million miles a sun, or
Yes.
one astronomical unit.
Yes. Thank you, Himalka. So next up, I said it is Sudit. Sudit. Sudita, are you there? Sudita, you can speak now.
Now the James Webb Telescope is aiming only. Now Mars has water, and you told that where there's water is life.
Mars has water, but Mars doesn't have liquid water, just like Earth. It has water.
Yes,
it has
water,
only
but
ice,
it's boiling
polar
water.
caps. It has polar caps on the north and the south poles of Mars. Okay, so
Yes, and
all right. Yes.
And life, bacterial life has found on Mars, but not like alien life. That's why the James Webb Telescope has launched in 2021.
Yes. Okay.
In December.
All right. Arudit also had, yeah.
And when the James Webb Telescope aims at the Goldilocks zone of the stars, like in the TRAPPIST-1 system, it can find any life that sustains in the planet. There are some planets that maybe can sustain life, maybe underground or up in the or somewhere.
Yeah.
And I have seen some videos. They have told that they think that some planets maybe have any alien life. So it's still they're searching for any alien life. If they found alien life, everybody will be proud, or if they are good or bad, we don't know. And I have seen some videos, and maybe they have any life.
Okay. All right. That's actually really yes. And really informative. So yes.
I have heard 3 Mars records from the Perseverance rover that picked up. When I heard those records, I thought was there any alien life? And then I saw one more photo that there was a Buddha statue. I don't know if I know that it's real.
We'll actually come to that, Sudita. So today you can actually note that down in a piece of paper or a notepad, because actually if you look at this month's plan, so today is the first week. So first week is solar system part 1. Second week, that is next Monday, we'll be talking about solar system part 2. And the third week we will talk about space exploration. So that's when we'll talk about these man-made objects which were sent to space and outer interstellar and all of that. And the fourth week, that's this month, we will be talking about extraterrestrial beings. So that's basically about aliens and all of that. So then you can talk about this. So you keep that in your mind, note it down in a piece of paper. We will discuss about that. All right. Okay. Superb for that, Sudita. You explained a lot of stuff. I can feel that you are really interested in this. Next we have Arudit. So after Arudit, the chance goes to Thyssen. Okay. So Thyssen, hold up. Once Arudit finishes, I will give you the chance to speak. Arudit, go ahead.
When the Mars was once a life planet which sustained life, still there's a theory that is still there can be water boiled under the ground, and there might be even microorganisms on the surface of the Mars. That's why some astronauts test their rovers that want to find microorganisms on Mars where there are. It's exactly like Mars on Earth.
Yes, sir. Okay, thank you. Next, Thyssen, are you there with us?
Yes, sir. Can you tell the question you asked? I didn't hear it.
Yeah, so basically now we were discussing about earlier we discussed about the sun, then the solar system, the formation of all of it, and now we finally discussed about the habitable zone, right? Or we call it as the Goldilocks zone. Why Earth is located as the third planet in our solar system, and why does Earth have life on it? So for this, a lot of people explain their ideas, the way how they interpret it. So Imalka explained his way of identifying it. Sudita explained, Arudit explained, and then Tisen, if you have anything to explain just like them, you can go ahead. Now it's the perfect time for you to talk about whatever you know about this habitable zone and why Earth sustains life, and what do you think about Mars and Mars atmosphere and all of that. Okay, I think Tisen is not there, I guess. Binal, what about you, Binal?
We think lots of places there are not oxygen, so we can't stay alive. And some planets don't have trees. Trees give us oxygen too. In Mars, if we grow something, it won't grow because it doesn't have too much sunlight because it's not near. If we go to Mars, we can't because it's too hot. If we go to Neptune, it's too cold. Those sites, because Earth is in the third planet, it has the equal thing what it needs. The place what Neptune is, it's so cold, and where Mercury is, it's so hot. So Earth is in the perfect place, so
Exactly.
we can stay.
Binal actually told a really important point. Thank you, Binal, for what you call bringing that up. So Binal was like, Earth is at the perfect location. Everything is in balance for Earth. So that is actually a really good point. So what I want to highlight is we know that once you pass Mars, the next planet is a gas giant, right? So Mars is the last rocky planet. So in between Mars and Jupiter, you have the asteroid belt. So there are a lot of asteroids over there. So if Earth is not where it is right now, if Earth was somewhere close to Mars or somewhere else, the chances of being impacted by an asteroid is more. The reason why these asteroids are very less, or the reason why these asteroids are not heading towards Earth, is because it's being pulled towards Jupiter, because Jupiter's gravity is also
Excuse
very
me,
strong.
sir. The
Before Arudit,
Jupiter's
yes,
gravity is extremely powerful and it
yes,
has protected us from billions of years. But there
exactly.
are times when even Jupiter also put many comets to Earth.
So true. Yes, Imalka, go ahead.
The reason why we are in the third planet from the sun, because Jupiter has a huge gravitational force and the sun also have a huge gravitational force. They push and pull Earth at different directions that our planet's orbit is stable. If there is no Jupiter, we would crash into the we not only we, all the rocky planets would crash into the sun because
Yes,
of the sun's enormous gravity.
that's right. All right, that's actually very true, Imalka. And next, I think Binal, you explained, right? Do you have anything else to talk about?
No, sir.
All right, perfect. I think Tisen was there with us, and Tisen, we lost contact with Tisen. Tisen, are you there? Hello, Tisen, where is Tisen? All right, Tisen, I think. Yeah. Yes, Tisen. So have you got anything to share with us? Any questions? because I will be moving on to the next part.
I have excuse me, sir.
Yes, who is that?
I'm Tisan.
Yeah, yes, go ahead. This.
Mars is the fourth planet from the Sun and the second smallest planet from the solar system, being larger than only Mercury. In English, Mars carries the name of the Roman god of war and is often referred to as the Red Planet. The latter refers to the effect of the iron oxide prevental on Mars' surface, which gives it a reddish appearance.
And even Thyssen highlighted a really good point that about size of Mars and why Mars is red in color. And another thing that you all have to remember is that Mars is the planet where you will find the tallest mountain in our entire solar system. Can anyone tell me the name of that mountain? Let's see if you all
It's
know.
a volcano, and
Yeah.
it's on the tip of my tongue, but I can't remember.
Okay, so it is called Mount Olympus.
Hi.
Right? Okay. All right. Okay. Perfect. Okay. Thank you guys for
The full
sharing
name
about
is
that.
Olympus Mons.
Yes. So the thing is, thank you for that. So all of we were this session was really what do you call interactive, because I was able to explain it and then I gave you all the chance to speak as well. So that was superb. Next is the last agenda that we have for today's lesson. That is basically about solar and lunar eclipse. Now, before I go to the solar and lunar, I just want to ask a very simple question. I think Imalka, Arudit, Chirat, Binal might already know about this. So can you all tell me what is this terms solar and lunar? What does that mean?
Solar is anything concerned with the sun, and lunar is anything concerned with the moon. That is
Moon, exactly. Yes, Sudita where were you? You are missing. What happened, Sudita?
It is an astronomy word. Lunar.
Yes. Sudita, hi. I can see you, Sudita. Yes, go ahead.
Solar. Can I explain about the solar eclipse?
Okay. What about Shanuli? Shanuli has been really quiet today. I mean, she didn't speak anything.
Excuse me, sir.
Shanuli? Hello? Yes. Binal, 1 second.
Comes to and then it stays in the palena.
Okay, I think Sudita, your line is not that clear. I think it's better you check your internet connection if possible. Binal wanted to speak. Yes, Binal, go ahead.
Luna is a word what comes from the moon, and solar comes from the word because it comes from the sun's power.
All right. Okay. So basically, solar and lunar, there's nothing that complicated with those two terms. It basically means solar is anything to do with the sun, just like how Charit said, and lunar is with the moon, right? So it is what we are going to talk about right now is solar eclipse and lunar eclipse. Now, this is not something which is new to you all. This is something which most of us humans, even us Sri Lankans, have experienced it. I think more. Have you all ever experienced or witnessed the solar eclipse or lunar eclipse? Anyone?
Lunar eclipse about 3 times.
Yes,
Solar
I
eclipse
have
once.
seen, but only a little time. I have seen only once.
But we can it from our
One
eyes.
at a time.
It's
One.
hard for our eyes. We can. There's a machine that we can make from a box.
Yeah, you can actually keep an X-ray. You know X-ray, Binal, X-ray.
Yeah,
Have you seen an
actually,
X-ray?
can make
Yes.
it because it's a thing we can use.
I
It can filter out the
partial solar eclipse that happened in 2020 or like around that
Yes.
period.
last year, right?
early,
I remember.
yeah, last year,
Even
early last year.
2020, I remember. I didn't went outside that time.
And we
I've seen
like
in
put some water in
2022
a
like.
big basket. So we put some
Yes.
water in a big plastic sort of tub, and then we watched from that the reflection.
that can also be done. Yes, Imalka.
Excuse me, sir. I have a question.
Imalka, Arudit, just 1 second. Once Imalka is done, I will give you the chance. Okay, Imalka, go ahead.
If we Olympus Mons is a dead volcano that had erupted before our Earth has formed. We actually don't know if it's just a mountain or actually a volcano, but scientists say it is a volcano. If you are standing on top of Olympus Mons, you don't know. Oh yeah, if you are standing on a mountain or not, because Olympus Mons is hidden underground, and it's almost three times taller than Mount Everest, or 2.5 times the size of Mount Everest. And
thank you, Imalka.
Because it's so big that you can see it even you are in space.
Yes. All right. Okay. So now we have actually another half an hour more, and then our lesson, our camp for today will be done. So before that half an hour, so we have a lot to cover. So one is the activity, and the other one, I just have few things that I want to discuss with you. Before that, we just have only one thing that we are lacking, and that is the lunar and solar eclipse. So you all have given me a really good idea of what solar is and lunar is, and most of you all know what it is. Which is superb, excellent. Thank you for those responses. Now I'll just explain what solar eclipse is, and also, yeah, another thing is that you all have experienced solar and lunar eclipse in your life, right? So some said that they have experienced it 3 times, some said 2 times. So whatever it is, you all have experienced it. That is what matters. So now I'll explain to you all what solar and lunar eclipse is all about. It's something which we all know basically, right? Most of us know. So solar eclipse is basically when the moon gets in between Earth and the sun. So what does that mean? So that basically means is we know that the Earth is revolving around the sun, right? So sun is stationary in the sense it's fixed, its position is fixed. So it doesn't revolve around anything. I mean, it does go around the galaxy Milky Way, but when it comes to Earth and the sun relative to the Earth and the sun, Earth is what revolves around the sun, and sun doesn't revolve around the Earth, right? So we know that. So when the Earth revolves around the sun, we can see that the Earth always, right, almost every day receives sunlight, right? So when it's night, we don't receive sunlight, and when it's morning, we always receive sunlight, especially in a country like Sri Lanka. Since we are a tropical country, we don't have winter and all of that, so we always receive sunlight, right? But what happens is when this moon, so moon has different phases, right? I think we all know about it. So we have this Poya day, right? So every month we have a Poya day. So what is basically a Poya day? Poya day is when the moon is in its full shape, right? A full moon. So that's when we call it as a Poya day. So does the moon remain a full moon throughout the month? No, right? The moon's shape starts changing. It's a full moon, it's a half moon, it's a crescent, like that. Its shape change starts changing. Now it's not the shape which changes, it's actually the reflection of the moon which is visible to us which changes, right? So similarly, what happens is now the Earth and the sun, the Earth revolves around the sun. The position when the Earth revolves around the sun, what happens is the moon comes in between the sun and the Earth. And when that happens, what happens is that you feel like, you know, the sun is starting to disappear. You feel a portion of the sun is disappearing, and then the half of the sun is disappeared. Then you see 3/4 of the sun is disappeared. Sometimes you might feel even the entire sun is disappeared. When you feel like the entire sun is disappeared, what is basically happened is that the moon has come directly in front of the sun. Now, since the moon came directly in front of the sun, there's no way that the people who are living on the earth can see the sun directly. All that they can see is the moon. And that is basically what solar eclipse is all about. Understood? Right. So now I'll just show you a diagram, right? So a diagram on the internet.
Excuse me, sir.
Yes, who is that?
I am Tisan.
Yes, Tisan, go ahead.
In 4th of December 2021, it has been an eclipse.
Yes. So yes, Tisan. Yeah. So here, can you see this photo? Can you see? Here you can clearly see that the sun is behind, right? Here. This moon is starting to move. That's the reason why over here in this position. Right. So in here, this position here, can you see? It's becoming brighter. So it will become more brighter and brighter and brighter and brighter. And then finally, what do you call it? Will get back to normal. So that is basically what a solar eclipse is about, right? So let's stop share. Okay, then what about lunar eclipse? Now, solar eclipse, we know solar eclipse is basically the moon coming in between the sun and the earth.
The lunar eclipse is
Yeah. Sorry.
Lunar eclipse means when our moon go across our Earth's shadow.
Lunar eclipse is basically the opposite of a solar eclipse, where in the solar eclipse the moon covers the sun from the earth, like the moon gets it between the earth and the sun, but in the lunar eclipse the earth gets in between the moon and the sun.
Yes, right. So we know that when you take the sun and the moon, the sun and the moon, we know that these two celestial objects are basically, as humans, we know that these two objects are what illuminates the earth, right? Illuminates in the sense, gives light to earth, right? So we say, okay, the sun gives light to us during daytime and the moon gives light to us during the nighttime. But what we always forget is that the moon does not give light to earth. Moon, what it basically does is it reflects the light from the sun onto earth. So that's a difference. Now sun is something which can give out its own light. It can produce its own light, but moon does not have the ability to produce its own light, because there's nothing to produce light in a moon. Moon, what it basically does is it reflects the light which is shown onto it by the sun, right? So then if there is no light, being shown onto the moon, in the sense if there is no light entering the moon's surface, then definitely the moon will not be visible to us. Okay, just imagine if I destroy the sun, will I be able to see the moon tonight?
No,
sir.
No. Exactly, right? So why? Because the sunlight is not there in order for moon to reflect it back onto earth. So basically, like how Chirath explained, what happens during a lunar eclipse is the the earth comes in between the sun and the moon. So then there is no way that the sunlight can be reflected onto the moon's surface. Since the sunlight cannot be reflected onto the moon's surface, people living on the earth will not be able to see the moon. And that's the reason why during a lunar eclipse, we are unable to see the moon, or we see that the moon is starting to disappear. All right, so that is basically the solar and lunar eclipse. So today's camp is almost over and we just have only 20 minutes of our time. So before we start our discussions, there are a few things that I want to talk about. One is the activity. I'll finish the activity and then we'll move on to the discussion. All right. So today, what we basically have an activity is we are not going to do a very hard or strenuous activity, but don't worry. In our coming weeks, next week and the week after that, during our camp, we have really I wouldn't say difficult, but I would say a bit of a challenging activities. But since this is our first class, I don't want to keep it more challenging because it will just bore you all out. So today's activity is basically to draw your favorite planet and its natural satellites. Okay. So it can be the 8 planets, one of the 8 planets, or it can also be a dwarf planet, whatever planet you like, but it has to be a planet from our solar system. Okay, so you draw that planet as it is as much as possible, right? So now, for example, let's say if you all want to draw Mars, don't draw Mars and color it blue. You get what I'm saying? So if it's Mars, it has to be red in color, right? So try to keep it as natural as possible. Give your maximum. It doesn't have to be like, exactly like how Mars is, but try to do your maximum, because whoever does the best will definitely get an award at the end of the camp. So yeah, so I believe that Imalka, Chirat, Tisen, Sudita, Shanuli, Binal, Arudit, all of y'all are very highly interested, and all of y'all are highly excited when it comes to astronomy. So I believe that you all will do a really good job. So you just have to draw your favorite planet, and then you have to draw its natural satellite. But for example, if you are going to draw planet Jupiter, we know that Jupiter has a lot of planets, right? We have 59 planets for Jupiter. Sorry, 59 moons for Jupiter, right? Natural satellites. So you can't be drawing 59 satellites now. It's impossible, right? So at that instance, what you do is you research the top 3 satellites and you draw them. The top 3 satellites which you feel like you are interested, you draw those 3 satellites. So you draw Jupiter and 3 satellites.
Can we when we draw Jupiter, can we just get the three satellites that you know about and write?
Yes. So whatever out of those 59, whatever you feel like you're interested or you're curious or you like, you draw those 3. Because if you're going to draw the entire set of satellites which Jupiter has, then there is no place for you to draw, right? It's impossible. So that's the reason why if you select a planet which has so many satellites for it, then just draw only 3 satellites. 3 satellites is more than enough. All right, keep it as more realistic and more nice and more beautiful. The more nice, the more beautiful, and the most creative it is, the higher the chances of you winning a prize. Understood?
Can we?
Perfect.
Can we draw Jupiter's rings? Small.
Yeah.
Small rings.
Yes, you can. Try to, like, even you can also include the what you call the red spot, the red spot giant, the giant red spot, right? So you can also include that onto Jupiter as well. All you have to do is try to keep it as realistic as much as possible. Yes, and another thing that I want to talk is Shanuli here with us? Shanuli? Hello, Shanuli? Hello? Okay. And another thing, along with this activity, another thing which I want to request you all is to record a small video, right? It doesn't have to be a really lengthy video. It can be a very small video. So what you all have to do is today, once your camp is finished, right? Our camp will finish in another 15 to 20 minutes time. So once the camp is finished, record a small video of about 20 to 30 seconds, right? Explaining about any topic that you learned today in our camp, whatever topic that you feel like you're more interested, or whatever topic which you feel connected, just take that topic and explain it for 20 to 30 seconds, record the video and send it to Knox Ceylon Institute. Okay, so that's another task. So what are the tasks that you have to do today? One is to draw a picture of your favorite planet with 3 of its natural satellites, if it has more satellites. 2 is to record a video of yourself explaining a topic which you feel more connected or more interested, or what you have understood really well, for about 20 to 30 seconds, and send it to Knox Ceylon Institute. All right. And after you do that, and today, most probably after this class, I will be sharing you the notes for today's lesson, the links that I was showing you in which I was sharing, and also the lesson plan, right? So the plan, camp plan. So what is for this week, what is for the next week, the week after that. Suddenly, most of the students, Imalka, Tisen, Chirat, Sudita, Binal, Arudit, all of them were able to speak today. They were actively asking questions. Shanuli, why don't you ask questions? I didn't see Shanuli asking any questions today. Shanuli, are you shy? What's wrong, Shanuli? Aren't you interested? Hello? Shanuli, can you tell me how was today's class? Did you enjoy today's class? How was it?
Yes, sir.
Hello? All right, okay. What about Binal? Binal, did you understand the task that I gave today?
Yes, sir.
All right. So, what are the new things that you learned today?
How did the sun form and why is the earth in the place? Why
All
is
right. So,
the earth in the
so,
place?
so
where
what
it's
thing?
now?
Yes. So, what thing do you feel like you're gonna, shoot the video about? What are you gonna talk about in the video?
Why is the earth where it's now?
All right. Perfect. What about Chirat? Chirat, are you there?
Sir.
Yes, Chirat. So, what about you? Have you learned anything new today in today's
Excuse me,
lesson?
sir. I have a question.
Hello, Chirat.
Hello, can't you hear me?
Yes, I can hear you. Now I can hear you. Go ahead.
I did learn some things like basically how much the sun is, like that, those numbers 99.86, I think, like
Yeah.
numbers like that. I didn't know the numbers before, so
Yeah.
I learned that today.
All right. So, what do you think you're going to talk about in today the video the task that I gave
Excuse
you?
me,
I
The
thought
20 to
sir. I
30
am
how
seconds.
much
Arudit.
of it.
Excuse me,
Yes.
sir. I am
Yes,
Arudit.
Ardit, I can
have
hear
a
you.
question.
Yes, I'll give you the chance.
In the
Chirat, yes, go ahead.
video, if we
Yes.
talked about something that has another thing with it, can we say about it as well in the video?
I didn't understand.
Can we say something that is with it, with the topic we choose about the thing? Can we also take that with the topic to say about?
All right. Yeah, no worries. As long as the topic is related to whatever is covered today. Today's lesson is all about solar systems. So today we all learned about the formation of our solar system, everything that is there in our solar system. That's what we basically covered. So if you are interested in anything which is related to that specific topic, you can talk about. For example, don't talk about galaxies and stuff. About galaxies, you can talk when we discuss about galaxies. So since today is all about solar systems, you can talk something which you feel like you are interested, or whatever you feel connected in the solar system. You can talk about it for 20 to 30 seconds roughly. Got it, Arudit?
Sir,
Hello, Arudit?
excuse me, sir.
Yes,
I'm I'm gonna make a video that we didn't search in this class. Is that okay?
Yeah, so what is it about?
About the moon.
Yeah, so about the moon is nothing. It's basically that we will be covering it in the next week. Remember, I told you that the solar system is a really expand, like in the sense a very huge and expansive topic that we can't basically cover it in one day. So it's like this. So in today's class, you see, I explain a certain thing, and then I have to give time for each and every one of you all to speak. So even in today's class and all the today's plan, the topics that I have discussed today, even those we had very less time to discuss, right? I think you all would have noticed that even when we talked about the solar system and the solar eclipse and lunar eclipse, we didn't have much time to discuss about that in detail. So don't worry. So like I said, the solar system topic itself is really huge, and that's the reason why I have divided into solar system part 1 and solar system part 2, which means we will be talking about the moon, the meteor, the asteroids. There are so many stuff about the Oort cloud, the Kuiper belt. All of these I never covered it today. All of this will be covered in the next week class. Got it? So as long as Imalka has something related to the topic that we covered today in our solar system lesson, part 1 that we covered today, which you feel like you are more interested or more concerned about, you can shoot a video regarding that for about 20 to 30 seconds. Understood, Imalka?
Yes, sir.
All right. Chirat, you were speaking and then many others came in between, like there was an interruption. Yes, Chirat, go ahead.
I
Is there
thought
anything
of
else?
maybe including, like, I thought of maybe doing a video about the formations of stars, so how Mars lost its atmosphere, either one of those.
Yes, yeah, super. Because we actually talked about it, right, in today's lesson. So you can, it doesn't always have to be, it's like this. So whatever you all learn here, it doesn't have to be like, you keep that only that certain knowledge in your brain. What it doesn't, it's not necessarily have to be in astronomy. Whatever you learn, it's astronomy, science, geography, whatever you learn in this in your life, you shouldn't always be constrained to a certain topic, constrained to a certain textbook, constrained to a certain lessons taught by a teacher. You get whatever we explain, and you also have to do your research. Now, for a good example, you can take Imalka, right? So Imalka was like, he confidently, he was like, I didn't learn anything today. I have already known about most of the stuff. So that basically shows how interested he is. Like, he has already done his self research in most of the lessons, right? So just like that, even Chirat, we wouldn't have gone into much details about how Mars lost its atmosphere, how Mars became a very hostile place and all of that. We wouldn't have gone much into details about it, but you can definitely go into details, do a bit of research and shoot a video. And even if you get questions whenever you are doing your research, there might be few aspects where you get stuck. You might feel like, oh my God, I don't understand this. You write that down and you can always ask those questions in this astronomical camp, and that's the purpose why we have these astronomical camps, in order to help you guys clear your questions, clear your doubts, and answer as much as possible. Understood?
Yes, sir.
All right. Okay. So that is basically it for today's lesson. And another thing that I want to highlight is that if possible, from next week onwards, try to keep your cameras on, right? So the more you all keep the cameras on, the more easier it is for me to, identify who is asking the question, who is speaking, right? If not, I don't know where the sound is coming from, because I get confused. Sometimes Imalka might be speaking and someone else talks from behind, and I'm like, is that Imalka? Is that Thyssen? Is that Arudith? I get confused a lot. So if you keep your videos on, so today is fine. Today is just the first day, and so we have, like, we all humans, we all make mistakes, so that's fine. So from next week onwards, from next Sunday, try to keep your videos switched on. And also, if you all have any questions that you all want to ask, you all can note that down in a piece of paper or anything, and during the group discussion, you all can always ask those questions and we can discuss them as a group and come up with the question. Yes.
Excuse me, sir. Do we talk about neutron stars in this astronomy camp?
Yeah. This astronomy camp is 3 months long, Imalka. It's not just one day. It's not only today. It's 3 months long. So basically for 1 month, we have 4 sessions. One session is 3 hours long. So we are going to cover as much as possible. Space is the only thing in this world, just like numbers, it doesn't have an end, right? There's no start and there's no end for space. It is something which is growing every day. Every day, scientists are finding new stuff. Scientists are coming up with theories. Scientists are coming up with finding facts. Do you get it? So whatever facts, yes, Ardi, give me 5 minutes. Give me 5 minutes. Let me finish this and then I'll give you the chance to speak. Okay, Ardi, just give me 5 minutes. So you see, astronomy, we learn a lot of stuff. We get to know a lot of things. Now, for example, 15 years back when I was around your age, 10, 15 years back when I was in grade 3 or 2, we used to learn that Pluto was also a planet. But now look what it is. Now it is called as a dwarf planet. So just like that, we don't know what will happen tomorrow. We don't know what will happen the next day. But whatever we know now, whatever we have learned now, I will cover all of it in this astronomical camp. Don't worry, because it's 3 months long, Imalka. It's not just one day. So that's the reason why I have broken down it, because I can't explain all of it in one day. So that's the reason why today is about solar system part 1. Next week is about solar system part 2. And the week after that is space exploration. And the week after that is about extraterrestrial. And then we have about galaxies, we have about universes, we have about black holes, we have about wormholes. Everything that is there to be learned in astronomy will be covered. Okay, Rimalka, you don't have to worry about any of it. All right, understood, Rimalka?
Yes, sir.
All right, perfect, super. Arudit, go ahead. You wanted to ask a question.
Excuse me, sir.
Yes.
That means in the future many things can change, like is the universe is stretching to make it huge. That's why there's the Big Bang's explosion still going on.
Yeah. Now that's actually a really good question, Aruditas. Now, for example, remember I gave you during this lesson, today's lesson, I was like, I was showing you about the headset. Remember, I asked you what this is, and then you all were like, okay, this is a headset. And then I was like, in those headset, you have this. They have mentioned made in China, made in the year 2020. Like that, I was explaining, right? The reason for that is because all these things, these headphones, this mouse that I have in my hand, this phone that I use, this laptop that I have, all of these have a history that we all know about. But when it comes to space, when it comes to astronomy, when it comes to planets, when it comes to universes, when it comes to galaxies, no one actually has a definite answer for it. All these are just theories which have been brought forward by scientists. Even scientists who have brought these theories into existence, they are still researching on that, making sure whatever they have put forward is true or false. Even Big Bang theory, because Big Bang theory is the theory which explains about about creation itself. That's how scientists say, okay, every single thing that you know about the galaxies that you can see, the universe that is there, the observed. Yes, Imalka.
Scientists say that is the reason that the universe is expanding is because of the pressure of the Big Bang is still going in the middle of a universe.
Yes. So just like that. So what I'm trying to say is that now this Big Bang theory, do you think that Big Bang theory is a true? That it's 100% true? No, it is not. Big Bang theory is something which is accepted by most of the astronomers and most of the astrophysicists and most of the scientists. They just accept the fact that, yeah, Audit, give me 5 minutes, Audit. I'm explaining something. So once I explain, then I'll give you the chance. So what do you call the Big Bang theory is something which is widely accepted by people to be the creation of everything, but it is never the actual fact. Now, for example, if I talk about this headset, I can say that this headset was made in China, and it is definite that it was made in China. I mean, they haven't mentioned it for license. Will someone mention, okay, made in China, and then give me a headset which was made in Europe? No, this is something very definite. But when it comes to the universe, observable universe, when it comes to the galaxies, no one actually knows how this was created. So sometimes in near future, when you are like, let's say, when how old are you, Imalka? 10? How old are you?
9.
Imalka is 9 years old. Imagine when Imalka is 80 years old, 80, when he's an old man. At that time, they might say, Big Bang is not real. The universe was created using a different theory. It can happen. It will definitely happen sometimes. Because Big Bang is just a theory. It's not a fact. Understood? So that's the reason why astronomy is a subject which will definitely change in future. New stuff will be discovered. Sometimes the stuff which were discovered earlier will change later on. Okay, and another thing which I want to highlight is that, sometimes most few students might feel like, I'm learning whatever I know about. So the reason why it sometimes will be basic is because there are other kids over here in this astronomical camp who have no idea, who have zero idea about certain stuff, right? So we can't skip that and go on to the advanced side as well. And that's the reason why we have specially dedicated a group discussion session in our all our all our weekly camps. So week 1 we have a group discussion, week 2 we have a group discussion, week 3 we have a group discussion. Till the end of our astronomical camp we have group discussion for every single class. The reason why we have group discussion is because whenever a student feels like he has extra knowledge or he wants to ask a question which is a bit advanced, then he can ask those questions during the group discussion and we all can discuss it together and come up with an answer. But remember, when I started today's class, I was like, okay, I'm going to explain all of this and then give you all a chance to talk. This is the reason. Because when I explain from beginning, I will go from basic to advanced, because there are students who have zero knowledge about basics. Now, if I directly jump into the advance of astronomy, advance of cosmology, they might get, pressured. They might not understand. They might feel like, okay, what's the purpose of this? I don't understand anything. You get it? So it has to be fair on both the sides. So wherever I am explaining, you might feel like, okay, this is just basic. This is just something which I know about. Okay, I know what you all mean. I mean, I understand how it feels, but just you all have to excuse me, because the reason why I'm explaining like that is in order for the people who don't understand, in order to make them understand. Once they have understood the topic, then we have the group discussion. Then whatever you all know, you all can ask those questions in the group discussion. Understood? So then equally, students who know about astronomy and students who don't know about astronomy, both of y'all can learn equally. Okay? Perfect. Then I guess today's lesson is already covered. We did a lot of group discussions. I have explained you all about the rules and how this astronomy camp will go forward from today onwards. And we will what's the duration of the astronomy camp and all of it. So I hope you all understood, and I've given you all 2 tasks. One is to record a video about 20 to 30 seconds about whatever you all have learned today, or whatever you all are interested. It doesn't have to be something which you all have learned. Whatever is you all are interested about today's topic, you all can make a video about it. All right, awesome. Okay, so those drawings you all can send it to WhatsApp for Knox Academy WhatsApp number. I think you all have it, or if you all don't have it, you all can ask your parents anytime and send it to that. Okay, all right. So that is basically it. So I don't want to waste much of your time. And Tisen, are you there with us? I forgot to ask Tisen. Tisen, do you know what are the tasks that I have given you?
Excuse me, sir, can I say it again?
Yes, the task that I have given is that you all have 2 tasks. One task is that you all have to draw your favorite planet along with its natural satellite. So if you're drawing Earth, you draw Earth and Moon. And if you're drawing Jupiter, we know that Jupiter has a lot of natural satellites, around 59. So you can't draw all 59, right, on a piece of paper. Then what you do is you draw only the 3 favorite satellites that you like along with Jupiter, right? So that is the first task. And the second task is you record a 20 to 30 seconds video.
Can we
You can. And the second task is you need to record a 20 to 30 second video of whatever lesson or whatever interesting topic that you have learned today. Okay, Tisen? So those are the 2 tasks. One is you draw a picture of your favorite planet along with its natural satellite. Second is shoot a 20 to 30 seconds video of whatever you feel like you're interested or whatever you feel like you're concerned about today's topic. So if solar system means you can talk about anything about solar system. For instance, formation of our star or protostar, what a protostar is, formation of our star, what a protostar, how Earth is located in the habitable zone. Anything regarding the solar system, whatever you feel like you're interested, you shoot a small video about 20 to 30 seconds and you send it to WhatsApp. to Noxilon Institute. All right.
Okay, sir.
All right.
Yes, sir.
Awesome. Perfect. I think all of y'all understood, right? Chirat, what about you, Chirat? Got it right?
Yes, sir.
Yes. Binal, what about you? Okay.
Yes, sir.
All right. Arudit, okay. Arudit.
Yes, sir.
All right. Okay. Superb. Then I don't want to take much of your time. It's Sunday, so definitely you all need time to enjoy, relax, and do your personal, playing and watching movies and all that. Spend time with your family. So I'm gonna take much of your time. Thank you for joining today's camp. It was really wonderful. I hope all of y'all enjoyed, and I hope most all of y'all will join our next week session as well. So I wish you all good luck. That's it. Good evening, guys. See you all next Sunday.
Good evening, sir.
Good evening, sir. Bye, sir. Thank you,
Bye,
sir.
sir. Thank you,
Be
sir.
safe, sir.
Good evening, sir. Thank you, sir. Have a nice day, sir. Good evening, sir.
Good evening. Bye.
Bye.